Good morning, good afternoon, good evening, wherever you are. Welcome to the Hertie Data Science Summer School. My name is Simon Munzert, or just Simon. I'm Professor of Data Science and Public Policy at the Hertie School and Director of the Data Science Lab. And today we're going to go into the third edition of the DS3. The first Data Science Summer School launched in 2021. And since then, we've had over 8,000 participants. You can still access all the material from the previous years on our YouTube channel. And it's amazing that this year, again, we have so many registrants. So thanks for being with us. We have more than 6,000 people who signed up for our online courses this year. And I would like to give you a brief overview of the summer school. I'm sure you've already checked it out in part, but I want to make sure that you're aware of the full program. And then I want to say a little bit more about the people involved. And yeah, I'll not spend too much time on it because I know you're all waiting for the actual course to kick off. So as in the previous years, the summer school is split into two parts. In the first part, which happens this week, we feature sessions on data science fundamentals. So today we're going to start with an introduction to R programming. Tomorrow, we feature an introduction to Python. Wednesday then makes a shift towards, say, like another set of fundamentals, and that is like the math part of it. So Wednesday will feature an introduction to calculus for data science. Thursday will then focus on linear algebra for data science. And on Friday, that week of fundamentals concludes with a primer to statistics and probability for data science. Next week, we feature 3 more sessions on more advanced topics, namely a hands-on workshop on transformers and how you can fine-tune your own BERT and GPT. And we're going to have another session on generative AI. And that's going to be a hands-on session on how you can craft your own prompts and be creative with those tools. So that's going to be very exciting and fun. And finally, we are featuring a session on deep learning for multimodal systems. So you can see that the spirit of the second week is very much on like new AI tools on the block. I want to welcome one group of participants in particular, and that is our incoming students of our master's program of data science for public policy, or short MDS. For the first time this year, we are combining the online sessions with on-site labs for you to get your first exposure or a refresher, depending on like where you're coming from, of the fundamentals that we're going to work on more intensively in the months to come. And I'm very much looking forward to meeting you all in person very soon. Now, if you are, and this goes to all of you, if you're looking for opportunities to pick up more data science skills and to learn how to apply them to problems of policy and decision making, our full-time master's program might be what you're looking for. So it's a fairly unique program that features serious training in data science skills. And in that sense, today's summer school could only be the start of that, but also gives you the opportunity to learn more about how data science can be leveraged to inform policy and decision making. Now, if you want to learn more about our program and what it takes to, sign up and experience this at the heart of Berlin, that is where the Hertie School is located, just check out the program website or reach out to us directly. Now, before I introduce the instructor of today, let me give a big shout out to the person without whom none of this would have been possible, and that is Hui Deng. Hui is the manager of the Hertie School Data Science Lab and the coordinator of the DS3. Hui has spent the last months to set up everything that is required for this effort. So this included the setup of the website, the recruitment of instructors, the management of subscriptions. He took care of like advertising the summer school. So here's the reason why you are here really and like got to learn about that. He'll also take care of administrating the sessions this week and the next, and will even serve as an instructor for one of them. So let's all give him a big round of virtual applause for all his efforts. Thanks so much, Hui. That is an immense effort. Also with us are Dina Rabe and Carmen Garo, who are or were students in our MDS program. They'll be around today. Keep an eye on the chat. We'll be ready to engage should you face any issues. And I'm sure that's going to be a big help because, yeah, I'm seeing, we've passed the 300 participants threshold today. That is amazing. And I'm sure having both Dina and Carmen around will be useful to some of you. So thank you both for being with us today. Now, I know that you can't wait to get started with today's workshop, so let me introduce our instructor of today. Welcome, Fabio. Fabio Votta is a PhD student at the University of Amsterdam. His research focuses on micro-targeted political advertisements and how they impact citizens and society. So it's, I would say, one of the more relevant questions you could work on today, leveraging the computational tools that we have at our hands. And that is important. So he is a seasoned computational social scientist. He's an expert in R, has authored multiple R packages, and is, as you will experience on your own in a minute, a very passionate evangelist of the language and a very effective one, I'm sure. So Fabio, we're very happy to have you with us again, and I'll hand over the floor to you. And again, like to all of you, please enjoy this workshop and hopefully also the workshops to come. We're all very happy to have you with us. Thank you. And Fabio, the floor is yours.
Thank you so much, Simon, for this very nice introduction. I can say that this was probably a truthful introduction to me. So one thing to be careful about me is that I am an evangelist, but I would say as well that I recognize all values of all programming languages, just that I have chosen this particular path into data science, and all paths into data science are valid, I would say. But we are here today to learn R, and there's some reasons why I think R is a good language for data science, and we will explore this today. I also want to thank the Harthy School for inviting me for a third time to this introduction to R course, and it's always been a blast for me. And really, for me, I see this as an opportunity to bring a topic to people that some people might really find hard, and I found it hard for a really long time as well. And for me, it's really an opportunity to try help people with this something that could be quite tricky. And I found quite tricky as well. And for me, it's a way to give back sort of to society, because I learned so much from other people as well. So yeah, without further ado, I'll share my screen and we can start right into it. So I call this a fun intro to R programming because I want it to be fun. I don't want it to be frustrating and all of these things that introduction to programming languages can be. And I also want it to be so that I will pick you up from the very beginning. So if you don't have any programming experience at all, don't worry at all, because we will start at the very beginnings of programming. And if you have a little bit of experience or a bit more experience, I still hope that you find this useful as a way to learn a new programming language potentially as well. So some words already have been said about me. I'm currently a PhD candidate at the University of Amsterdam at political microtargeting. In fact, I'm going to turn in my dissertation in 2 weeks, so this is a perfect timing, but it's going to happen. So I'll be finished with my PhD in no time, essentially, as well. And I'm very passionate about R and data science, has been said. I love to travel. And I also underscore the fun in data science because I occasionally create some R memes about my experiences of errors and so on that I encounter. So there's some shameless self-promotion. If you want to go to my R memes Twitter account, you'll find some freshly made memes sometimes. Not currently because I'm focusing on my dissertation, but it will resume soon enough. Anyhow, but enough of me, enough has been said about me. There's a lot of people from all around the world here, and I really enjoy this opportunity, and I want to learn a bit about you. So here I prepared some interactive slides from Mentimeter. Maybe some of you might be already familiar with this. So I would ask you to maybe scan this QR code or go to menti.com and type in this, this code. So we can learn a little bit about who is here and who you are. So because I really am curious about this very diverse set of people that are listening in today to learn about R. So give it the opportunity to scan it, and I will go to the next screen in a bit. Also go to chat to see if there's anything. Okay, so let's see. Hopefully this works. So this should ideally, so you've submitted answers already? Yeah, someone could share the link as well. Someone is pointing on. It's not updating, maybe. That might be a problem. But please keep voting, because I will go to the actual Mentimeter website then. Because this is maybe a problem with that I'm hosting it within the slides. So maybe it's not updating the meter. It's unfortunate. TS23. Oh yeah, I can see it here. I can see it here. So let me try to get this to you. Unfortunately, I can't do a full screen, but it'll work as well. Okay, so here are the results of the current survey. So most of you are ready. That's great. I see some of you are vibing, which is also great. Some of you are a bit confused, and that is also very valid. And some of you are screaming. And I hope at the end of this introduction, you'll not be screaming anymore. And I hope that you also were able to go to the second one. Or maybe you weren't able to go to the second one yet. There should be a second input as well about what is your study and where you come from. But if it doesn't work, we'll maybe have to just do it via chat. Let me see. Oh, now it's updating here. I was a bit too. Let's see. It did not open for me. Okay, well, you know, technical difficulties is a thing that always happens in these kind of live things. So I would say maybe in chat, you know, just mention what your field is, your study field, and where you're from. So so we can know where you like. I'm really interested in the diverse set of people that are here today. And unfortunately, the technicalities are not working out. All right, I see a lot of people from India, Italy, Russia, Switzerland, China, Armenia, someone from Toronto, Egypt. A lot of people here. Love it. Hong Kong, some Harty School from Germany. Yes. So cool. Yeah. Ideally, this would have been a word cloud, so you could see it like all yourself, like the, you know, all different fields, but not working out currently. Well, thanks so much for joining today. And then let's go ahead. Okay. So I already mentioned that learning R can be somewhat frustrating at first, maybe as well, and like learning any programming language. But for me, it really was a journey where in the beginning it was so frustrating, but now I feel that I finally broke through something that I can say I know what to do, but it takes a little bit of time. It takes a little bit of a, I also want to be honest with you, it takes a little bit of time to adopting this, but it also can be a fun experience. And that's what I'm trying to do for you today. And I can promise you it gets better as you go along with it. And also I would say particular to R, this is because there is a really awesome inclusive community that is always ready to help. And I've learned so much from this very active blogosphere that's out there. There's so many blogs, there's so many tutorials that people do for free. And it really inspired me to do these kind of workshops as well for other people. So because I learned so much from them, and it's a way for me to give back to them. And I also want to make a note on live coding. As you've already seen, when things are live, some things won't work out, and it's just the way it is. And I will be writing some code for you. You'll be watching me, and I'll maybe make some mistakes, and that's just the way it is. I will try to keep track of the chat, and you will tell me that there's some mistakes. You might laugh at me, but that's also okay, because we're all here to maybe make mistakes, and then we'll fix them together, and we'll figure out what is wrong, right? And even I, as someone, I should mention that I've started using R in 2012, I think. So at this point, I do have some experience in it, but even I make very silly errors sometimes. I misspell things and so on. So it's going to be a journey where we're in it together, I would say. All right, so an overview of what we're going to do today. So we were going to learn the very basics of R. It's going to be involving operators. So what are objects? We're going to write our own functions, and we're also going to do some exercises and learn about data frames. So we're then going to do a break at 2 p.m. Central European time, and I also wrote down a couple of other notes here as well, in case you're in a different time zone, but it's roughly like 1 hour and 40 minutes from now. And after the break, we're going to start into data manipulation. So how do we actually engage with data in R in such a way that we can conduct data science with, essentially? And here we're going to learn the suite of tidyverse functions, which I think in R is most suitable for using or for conducting data science. And in the end, we're also going to have some exercises, and you'll also have the opportunity to ask me some questions about R and everything related to that as well. So what is R? R is a statistical programming language, and it's been specifically developed for data analysis and visualization. So other than other programming languages out there, which you can also do data science, for example, Python, R is specifically meant for data science or for statistical analysis, which gives it some upsides, I would argue. And what is RStudio? Well, RStudio is an integrated development environment. It's essentially the environment in which you can use R in, right? So R is a programming language. RStudio is the company, was the company. They changed the name to Posit because they want to expand on the, they don't want to be bound specifically just the name R. They were doing some Python stuff as well. But RStudio is the interface with which you can work R in. And here you can write some R code, you can save files, and also provides the typical upsides of using an IDE, for example, syntax highlighting or autocompletion. But why would you learn R, right? So I would already mention that there is an amazing community. For example, I've always been very active on Twitter, where there's a really active community of people that use R under the hashtag #RStats. I think lately, I should mention, this maybe is changing a bit due to changes on the platform. But I'm still on the platform, and there's also a lot of people on there as well. But so far, it's really been really helpful for me to connect with people. And maybe there's also these emerging social media platforms. You'll find some hashtag #RStats people there as well. I would also say that data wrangling is accessible and fun, right? So there's this whole suite of tidyverse style functions that really make the most problematic aspects of the most tricky aspects of data more accessible. And I think that is really important, because 90% of what you're going to do in data science is not the modeling, the fancy stuff. It's going to trying to get your data into shape. And R, I think, is very well suited for performing this specific task, like putting data into the right shape for you to conduct the analysis. And it has an outstanding repertoire of statistical and computational methods, right? So here I just highlight the, yeah, please can you not write on the screen? I'm not sure if that's something that someone can change so that the participants cannot write on the screen currently. I'm sorry. But anyways, there is this package verse called EasyStats, in which you can there's a lot of different statistical techniques and data visualizations that are meant to be easy and accessible. And I think easy and accessible is the most important thing about a programming language, because it's already difficult enough by itself, right? So this is another upside and why you should learn R. And it actually also integrates well with other programming languages. So there is this package called Reticulate in which you can use Python within R. And since I'm mainly using R, I typically, whenever I have to use Python, which sometimes does occur, I'll just use it within R. And there's no problem with that either. So I really do like this particular option as well. And finally, there's some really beautiful data visualization you can make in R. And that's mainly due to grammar of graphics called ggplot. And here's an example from a colleague of mine called Cedric Scherer, and he does really beautiful data visualization. And that is something that is easy to do and really native to R as well. All right, another upside of using R is so-called R Markdown. And R Markdown really is powerful because it combines text and code into one unique syntax style. So you can mix, for example, your graphs, you can describe your graphs, and you can directly output your graphs into a document and create different kinds of documents. So for example, I've written my master thesis within R Markdown, right? I've created these slides that you're currently looking at in R Markdown, right? You can do dashboards, you can do all kinds of apps as well, with Shiny apps, for example, where you can also use R Markdown to create them. So R Markdown is a really powerful tool that I use all the time, and you will also be using today. So roughly how it looks, so, or like a difference between an R script and an R Markdown script is R scripts typically just end with R, and that's just plain text. Whereas an R Markdown is an .rmd, and that mixes code chunks with outputs, and also text describing those outputs as well. And here's just an example of how I've done my master thesis. So the plots you can see in this graph, for example, are all directly generated from code and put into a LaTeX style output. So it's also compiling into LaTeX as well. All right, so we'll switch to RStudio in a moment. Given a lot of introductory talks already, you can find all the materials under this URL, which also hopefully will be shared in the chat. And I hope you've also already followed the pre-workshop instructions, right? Which told you how to install R and install some of the packages that will be needed for working in today. If for any reason it didn't work out for you to install R on your own computer, maybe because you're using a work computer or something like that, then there's some other options. And I see someone, Carmen is raising their hand. Yeah, so you can.
Yeah, very quick. Just to the person who made the red circle, could you please delete it? I mean, only the person who made the circle can delete it.
Okay.
So just sorry for the interruption.
Yeah.
Fabio, sorry, can you go to your shared screen? There's a button called Annotate, and then you can see a button called Clear, and then you can clear all drawings there.
Clear all drawings. All right, done that. Thanks.
Thank you so
Sorry,
much.
I'm actually not that experienced in online teaching, which is interesting. I have to go in, but thanks for telling me. Absolutely. Thank you. So I know that now. Okay. So if for any reason you couldn't install R or RStudio on your computer, there's two alternatives. One is Binder, which just launches an RStudio session within your browser with all the materials already downloaded there as well, so you don't have to worry about that. And the second option is Google Colab. And Google Colab runs actually a Jupyter notebook within you can run R, and already prepared scripts, which are going to be exactly the same scripts that we're going to be looking at today, just within the Google Colab environment. The reason why I want to go with a local RStudio installed this time around, I always switch it around a little bit, but this time I want to do a local RStudio because I want you to be already ready after this talk to actually use R, right? If you're going to use it within a browser, or if you're going to use it within Google Colab, it's going to be a bit of a different experience on which you're typically going to use RStudio in. So there's some ups and downs towards using it locally as well, because maybe you can't install it, maybe there's some packages, maybe there's something specifically about your computer that doesn't allow you to do it. There's always some trade-offs here, but I want you to be able to follow along no matter what your circumstances are. Okay, so after you've downloaded the workshop files, it should look something like this. So after you've actually extracted also the files into its own folder, I want you to click on the following file, which is ds3rintro.r project. And that should open RStudio and specifically the project of this intro as well. So please do that now. ds3 intro R project. And once you are within RStudio, you would see 4 panes. And on the lower right, it should have a pane called Files. And here I want you to click on 01R Basics. And if you click on 01R Basics.rmd, it should open up a file script on the upper left. And there I want you to click on Visual. And then we're going to engage with visual mode so we can actually have all the upsides of looking at a notebook environment within R Markdown. Okay, I hope this is working out for everyone, because then I will switch into my own R environment. So this is how it looks like for me. And here, I'm going to tell you a little bit about just the basics of the IDE. So on the upper left, you can find, oh, I think someone raising their hand. Yes, please.
Hi. Could you repeat the steps of opening that file? I think I got lost.
Sorry, it was a bit quiet.
Could you please repeat the steps of opening the downloading the file and opening it?
So I think we need to go ahead right now. So maybe in chat, someone can help me with that particular part. So essentially, it's just downloading the file and clicking on 01rbasics.rmd, right? And then you should be, oh yeah, and then you should be looking at this particular R Markdown file. Okay, so first of all, I do want to explain the IDE real quick for you. So on the upper left, you should see R files. So for example, this is the 00.r file. And here you can run some R code and save files. On the lower left here is the console. You can also run code, but this is not for saving files. This is just for doing some quick operations. On the upper right, you'll find environment. That's the most important tab here. And here's where your objects are going to be stored. But I'll get to what objects are in a minute as well. And on the lower right, there's going to be your file structure within your R project. So here you can see all the files that should ideally be downloaded and be ready for you to use. If you go to the 00R file, we've written already some code. And typically in R or any programming language, you want to print hello world. That's a thing that you want to do when you learn a programming language. It's kind of like a meme at this point. And if you want to run this code, there is this button here. We're going to, for example, we could highlight it or just click in the same row as this code exists. We're going to highlight it for now and click on run. And it's actually going to run the code. And within the console, we'll get the feedback of what we ran, right? Now, this is how you typically might write code in any programming language, but we're going to use R Markdown. And R Markdown is a bit different. R Markdown typically have some kind of header. So these have some meta information about your document, but you can also see that there is some styling of the text as well. So there's, for example, a header that is bold printed. There's some links in here. And most importantly, there is what R Markdown calls chunks. And these chunks are essentially windows into the programming language. So here you cannot execute code, but within these chunks, you can execute code. So for example, this creates a summary of the cars data set that is typically within, it's a native data set within R. And this piece here actually tells you which programming language you can use within it. So you could also run Python code within here by changing it to Python. You could also run JavaScript, shell code, and so on. So this is actually programming language agnostic of what you can do. Okay, so these are the basics of R and R Markdown scripts. And now we're actually going to jump into learning R. So at the very core, R is a calculator, just like any programming language, really. You can do addition with it, you can do subtraction, multiplication, and so on. So for example, and I also would encourage you, as you are in the script as well, to maybe change some values for yourself, right? And just try out a little bit about what kind of changes you can make to the script. So here we just do 15 plus 5. We can click on this play button here to run the code. And then, for example, that would be 20, right? But we can change it to our heart's content, right? 15 minus 2. My work, yeah. And then, of course, that would make the calculation, right? We can also mix operators. We can do plus and to have brackets and divide things as well. So very simple and very clearly like a calculator, right? Another important thing about R notation is that you can use comments. So these hashtags here basically mean that the code, whatever you write here, will be ignored, right? So these pieces here mean do not run this code. I will just use it for annotation essentially, and that's the same as in Python as well. All right. So as you've seen, these two pieces here will be ignored, and only this piece here will actually result in some output, which in this case is 8. Okay, well, it's not that interesting to just run random numbers. So I've provided you here with a data set that actually concerns animals. And everyone loves animals. I love animals. So I hope that that is a more fun way to introduce it to our data sets. So we're going to use this animal aging and longevity database by the Jon Snow Labs, which I don't think is related to Jon Snow from Game of Thrones. It's also spelled differently, but it has data on over 4,200 animals. And it has some information about the gestation and also the longevity in years. And I thought it would be fun to calculate what people sometimes do is they say, how many years does your dog have in human years, right? And the typical rule of thumb is to say a dog year is 7 human years, right? And there's actually like some research into how to calculate, how to make this conversion rate work for several animals. But I'm going to tell you like a very simple way to do it, and that's how people have done it in the past as well, is they're going to use the maximum lifespan of a human, and that is the maximum lifespan that's ever been observed in a human, divided by the maximum lifespan of a non-human animal, right? And that gives you a conversion rate, of which you can say how many years is how many human years is it in a certain animal. And there's some more information about this. If you're curious about it, I actually went a bit of a rabbit hole into calculating this metric, but we're going to stick with this very rough way to determine the conversion rate between human years and animal life years. So when it comes to human longevity, actually the longest documented person living is 122 years old. Which I found quite fascinating as well. And from this data set, we can see there is also a bunch of other animals and how long the longest living animal within that species has been observed. So here's a couple of these statistics. And now, for example, if we wanted to calculate dog to human years based on this sort of scientific method, we would divide the human maximum lifespan by the dog maximum lifespan, which would be 24. And that gives us a conversion rate of 5.1, right? So one dog year would be 5.1 human years, right? So it's the typical 7 years is a bit off, right? But not off by so much. So now you could say, for example, how old is a 15-year-old dog in human years, right? So then we would just use this conversion ratio and multiply it with 15, right? And that gives us 76 years, right? So a senior dog would be 15 years old, right? So that works quite well. Now, we don't want to just use numbers like this, right? We want to actually be able to be calculating more complex calculations as well. And here to do that are so-called R objects. And one guideline that you can remember is everything that exists in R is an object. So everything that you can use in R is a so-called object. And this object is essentially a way to save information, save numbers, save data sets, save lists, vectors, and so on. And we can create those objects in R by using the assignment operator. And that's what it looks like. This is more space. So this is what the assignment operator looks like, right? So it's a greater than and a minus. But we could also use an equal. And if you've used Python before, this equal sign might be more familiar to you. But within R, it's typically recommended to use this arrow symbol, or the greater than and minus. Just because there's maybe some confusion sometimes, because the equal sign is also used in other contexts, and this arrow is only used within assignment as well. So that's typically why it's recommended in R to use this. And I would say 80% of the code you will encounter in the wild does use this. So that's how we're going to use it today as well. So if we want to hold this information about human lifespans and dog lifespans into a particular object, then we can assign these numbers that we had before into an object called human lifespan and to an object called dog lifespan. So we're going to do this right now here. And then in the next chunk, if we run this code, human lifespan, which is the object that we saved in this number, then we will retrieve this number, right? So it's kind of like a placeholder for this number then, because we assign it to this object. And similar with dog lifespan, now this variable holds 24. And remember when I told you about this upper right panel, the environment, now we can actually see that within the RStudio environment, we have those objects listed within the environment. And we can always reference to what kind of objects currently exist within our environment in this pane here as well, right? So sometimes you'll get errors like dog lifespan not found. Essentially, like, let's actually do something here that this object doesn't exist, right? And if I run this, it says object dog lifespan not found, right? And if you see here, well, this object hasn't been created, right? So it cannot be recalled by the environment, right? Let's move this again. So if you have any error like this, it means the object currently does not exist, right? Well, now we can also calculate the same calculation that we've done before. We divide the human lifespan by the log lifespan, but we can do that with the objects instead of the numbers, right? Which also now makes the code much more legible, right? So before I assign it, actually, let me just run this calculation, right? So we use the object to calculate the human to dog years conversion. And then we can also assign this calculation to another object yet again, right? And we'll call this object dogs to human. Now, if you run dogs to human, that's going to hold this new object that we just assigned it to, right? And with this object, we can also operate more calculations, right? So objects can be referenced with other code as well, right? With numbers, and you can perform calculations on them depending on what kind of type those objects are. So now I want to turn it to you, and I want you to try to calculate the cats to human use conversion ratio. And I want you to do it using objects, not with the raw numbers. So, so please go ahead within your code. I'm going to give you 3 minutes, I think, because it should be fairly straightforward. And then if you want to reference the cat maximum longevity, it's all the way up. It's all the way in this data set up here. So I'm going to give you a few minutes. Yes, so the materials, I think we can maybe also like repost the materials. How do I include the R? If I type it, nothing happens. Well, you would work inside these chunks that I already provided you. In case you want to create a new chunk, you can go to this plus C, and then you click on this plus C here, and then R. You can also see there's other languages as well, but we want to create an R chunk, and that's how you create actual code, right? Whereas the other parts are text. And then within this, like this slightly shaded part is where the window into R exists, right? Okay. Deleted it. Okay, so we'll see. What is the cat's maximum longevity? It's 30. The longest living cat has been observed to be 30. Quite a long time. So let's create an object called, using a different keyword. So what's the, okay. I'll have to copy paste this one because I'm using a different keyword that I'm not used to. But we're using the Simon symbol, and 30 was the time, the maximum lifespan of a cat. And the human lifespan we already assigned, so we already have that, so we don't have to assign it new. And then we can just divide the human lifespan by the cat lifespan. And if we run this code, because I have to run the entire thing because cat lifespan doesn't exist yet, it's 4, right? So 1 human year is 4 cat years, right? So we're gonna assign that a new object, and we call it cats to humans. And then this one, we're going to calculate how old is a 15-year-old cat in human years, right? So in the next chunk, we'll do this times 15. And then we can see a 15-year-old cat would be 61 years, 61.25 in human years, right? Okay. So you've seen me already writing a lot of objects, naming a lot of objects, right? And there's one quote that is, there are only 2 hard things to do in computer science: cage invalidation and naming things. Trust me, you don't want to specifically know what cage invalidation is. It's complex, but it's on par as naming things, right? So the way I've named things and the way it's kind of recommended by the Tidyverse style guide is so-called snake case. So snake case is everything lowercase with underscores between words, for example, right? But there's also other ways, and if you learn other programming language, you might have learned camel case or different kinds of upper camel case, for example, as well. But here we're going to use snake case, right? And one other thing I should mention is I've used quite expressive object names here, right? So cats to humans, human lifespan, and so on. But you can really name them whatever you want, right? Whatever is most convenient to you, and whatever makes you remember what the actual object is that you're creating, right? And you know, we could have created something here about cats are cute or something, right? And we can run this, and if you look here, there's an object that's called cats are cute, right? Is that the best way to define an object? Well, maybe questionable, but it's up to you how you name things. And ideally, you'd name them so that you remember what's in them. All right. So the recommended way would be lowercase with underscores and not ideally with dots or uppercase, camel case here in this case. But it's up to you, whatever is the most styling guide. I'm going to use this particular styling guide. So now we get to logical operators. So you can create so-called logical operators that you can use for logical tests, and they typically evaluate to either true or false. So it's also called a Boolean if you are familiar with other programming languages. So before we're going to run some of these logical tests, I'm going to create a few more objects so that we can run some logical tests on them. So for you, you should also click on this play button here. It always jumps a bit. But if you click on this play button, it jumps because I have selected up here. If I select it not up here, then it stays here. All right. So we've created all these lifespans for lifespan objects for all of these different animals. And now we can use operators to ask questions about the data, essentially, right? So for example, the equals sign asks whether some values are equal to each other, right? And now we're going to ask, is the lion lifespan equal to the boar lifespan? And if you run this code, it evaluates it true, and evaluates it true because the lion lifespan is 27 and the boar lifespan is 27, right? So essentially we're asking, is 27 equal 27? And that is of course true. Then we can also ask if something is not equal, right? where the two values are not the same. So if we're going to ask, is the lion lifespan unequal to the boar lifespan, then that evaluates to false. Why does it evaluate to false? Well, because they are the same value, right? So they should evaluate to false if you ask that question. And typically this exclamation mark is something that you use to say not, right? That's in other programming languages as well, where the exclamation mark means the opposite, sort of, right? Rather than the equal sign. Now we can also say, for example, is a value greater than or smaller than a certain value. So greater or smaller, just the way you could imagine it, is just the greater than sign. And we can ask, is the human lifespan longer than a fly lifespan? And if we run this code, that's true, right? Because obviously a human lifespan is longer than a fly lifespan. In fact, a fly lifespan is 0.3 years, a maximum observed. And then we can also do the other way around with less than, right? And here we ask if a mouse lifespan is bigger than an alligator lifespan, and that's of course false, because an alligator lifespan is longer. And then we can also use greater or equals, or smaller or equals, by using the greater than sign and then an equal sign after it, right? So 20 is 20 greater than or equal to 20. Well, that is true because it is at least equal to it as well, right? Okay. All right, so these are some logical objects or logical operators to do logical tests with, but we can also combine these logical operators. And if you do data science, you typically don't want to just test for one particular thing. There's going to be a couple of other things that you have to do. So for example, if we want to combine and test whether the alligator lifespan is bigger than the mouse lifespan and the fly lifespan is bigger than the mouse lifespan, that's how we might concatenate them with the AND symbol, right? So this AND symbol stands for, as you can imagine, AND, but there's also an OR symbol. So the OR symbol is just a vertical bar, and that says whether the part on the left here is true or the part on the right here is true, right? So let's first go and do this, right? So the alligator lifespan is bigger than the mouse lifespan. I think that's true. And the fly lifespan and the mouse is bigger than the mouse lifespan. Well, I think that one is wrong, probably, right? So this part evaluates the true, this part evaluates the false, but this AND here says that both should be true, right? So if we run this, it's false, right? Because this part here is false. And I can show that to you by just looking at this part. This part evaluates the true. The alligator lifespan is bigger than the mouse lifespan. And this part evaluates the false because the fly lifespan is not bigger than a mouse lifespan. But both of these statements need to be true for the entire statement to evaluate to true, right? In this case, it's false then. But if we say the or, right, if you use the or sign, then this would evaluate to true. Why? Because this part is true, this isn't, but it's okay for if only one part of the equation essentially turns true for the entire thing to be true. Okay, so this is how you can combine logical tests. But now we've basically just looked at single values, right? And essentially, you don't want to look at single values. You want to look at combinations of values, right? And within objects particularly. And in R, a lot of things are based on vectors. And these vectors, you can imagine, are just lists of values. They're not lists because there's also an object that exists called lists, but you can imagine them as lists. They're just listing out specific values, yeah, right? And to create those vectors in R, you would typically use the C function. And C stands for concatenate. So you concatenate different values together, so 1, 2, 3, and 4, to create a vector, a list of values. And if we run this, you can see that it created this, this list of values, right? If we wanted to create actually a list, then we would just use the list function, and that creates a list that looks like this. We're not going to concern ourselves with lists in this particular workshop, but know that this is an actual list in R, but we're going to use C as a vector. Okay, so now we can combine the various lifespans that we created and also assign it into from the objects that we had earlier, right? So we have the green leg shark Greenland shark lifespan, the log lifespan, and so on. And then we can create a vector of all of these objects that we've created. Now, these are numbers, but there's also a way to have text within vectors as well, right? So here's essentially the names of these animals, of which there are the lifespans. And if we run this, it's a vector of text or characters in R. So if we wanted to combine all of these values into one particular object, then we would do the concatenate and assign it to animal lifespans. So we'll do this now. And then if you run, let me actually also run this animal lifespan so you can see it, then that's the same thing we did up here as well, right? All the values are now within a vector. And if you're asking what this 1 here is, that's actually the index, and R starts with an index of 1. Cautious for the Python people here, because R starts with 1, Python starts with 0, right? Not going to start any fights about what makes more sense. That's just the way it is in R. And I'm going to talk a bit more about indexing in a minute, but just that you know that this particular one refers to the index of the first value. Now we can also run calculations on vectors as well, right? So we have the human lifespan, which remember is only 1 value. Exactly here, 122. And then we have the animal lifespans vector, which holds a bunch of them, right? And now if we divide human lifespans by animal lifespans, we can see that the calculation is performed for each vector. And that's kind of the default in R. So if you have multiple values and you perform an action on them, it's gonna remain in the setting where it has the multiple values. It's not going to do it. It's not going to output just a single value, for example, right? So typically it stays within the number of elements that it has already. So each operation is performed for each item separately. And now we can also, for example, assign this output to a new object called animal to human ratio. So we have all the animal to human ratios in one object. And now we can also perform logical operators on these vectors, right? We can ask, for example, what are all the animal to human ratios that are below 1, right? So in this case, it would be giving you a vector of true and falses, right? So if you look at the first animal, it's the Greenland shark, right? And that one lives much longer than a human, right? So then the animal to human ratio would be below 1, right? And that's in case also true, right? And we have false for the second one, which is the dog that lives a small amount of years than a human, right? That would be above 1, so it's false. And the third one is the Galapagos tortoise, which lives 177 years. That would be a conversion ratio of below 1 then, and then that also evaluates to true, right? So we're performing this logical test for each of these elements of the vector. So I already kind of mentioned that there are different kinds of variable types, and now I'm gonna actually tell you like what kind of variable types that exist in R. So there's this function called class, which tells us what variable type and particular object is. So if we run class on, for example, true, which remember is a Boolean binary true or false, then it tells us it's logical, right? So that's the kind of object true is, and the same is goes for false as well, right? Now there's also characters, a string, which is essentially just text, right? And that gives us the class of a character, right? That's how it's referred to in R. And then there's also numeric variables. And with numeric variables, you can perform calculations with, right? You cannot perform calculations with characters, but you can perform calculations with numbers, right? And so the class of 2020 is numeric, for example. And then there's also factors, and factors are just character vectors that are ordered in a way. We're not going to talk much about factors, but I wanted to mention it to you. So you can turn any vector, character vector into a factor by just calling the as factor function, right? And then if we choose the class of as factor, it returns a factor, right? And actually, good thing to remember is like these as dot functions, there's a bunch of them where you can convert different objects into different object types, right? So there's also an as date, for example, so you can create dates as well. There's a bunch of them. So let's actually see as factor. There's also as numeric and as character, for example, right? So these are maybe the most important ones. But that's how you can convert between the different variable types. All right. So there's also another important type of object, which is an A value. And this an A value stands essentially for missing value, right? So if you're familiar with Python, that would be an NaN, right? So this is just a stand-in for if you don't know what value it is. And that easily mixes with all the other types as well. So if you run this vector, which has NAs of 1 and 2, then that just gives us a vector with NAs in there as well, right? And also a note on mixing different kinds of variables. So typically what R does is defaults to the simplest form of an object, which is a character, right? So if I also include a text here, then it turns everything into characters, right? So that's what typically happens if you mix them, right? And ideally you shouldn't mix them. But the important thing is on this one now, you cannot perform any calculations because now it's a character vector. So if I run this, it says non-numeric argument, which in this case means, yeah, you cannot do times 2. If I remove it, it remains a numeric vector. Now do times 2, and that works, right? So times 2 of 1 is 2, and times 2 times 2 is 4, right? And it just ignores the missing values, which typically is what happens in R, but there's some functions where you have to explicitly say ignore the missing values as well. But that's good to know that in this case it just ignores it. Okay. Someone asks, is there an array equivalent in R? So the array equivalent would be lists essentially, but it's not exactly the same. So there's no specific equivalent to arrays, I would say. And also, I'm not super familiar with Python, honestly, so maybe someone would disagree with that. Okay, so I want to show you one final logical operator, which is typically not really shown in these introductory courses, but I do think is extremely useful for performing logical tests. So that is the percentage in percentage operator. And this percentage in percentage operator essentially allows you to do logical tests with vectors, with a bunch of different vectors. So let's say we have a vector of animals that we want to create here. So this is the animals vector. And now we would want to check, for example, whether a giraffe occurs in this animals vectors, or Greenland shark occurs in this vector, or lion occurs in this vector, right? So we could do this by doing consecutive calls to equal signs. So we could do equal equals giraffe equals Greenland shark. And then we have to keep repeating the animals, right? We have to keep repeating the same object to test it all. And then the first one is true, right? Because, well, giraffe, because Greenland shark does occur, right? So Greenland shark does occur in this, so that one is true, right? And then if you go a bit further, there is a lion as well, right? So then that wouldn't also be true as well, because we're testing for lion as well. Now, you think like, oh, well, I could do this. I could write out all these animals and so on. But if you have a lot of animals to check, you would have to always repeat every single one of these animals and do the order sign, order sign, order sign. And you could run this, and that also gives you a vector with all the tests, right? But I think that is really hard to read and very difficult to write as well, right? Instead, what we can do is assign all the animals you want to check to a vector. So we want to check whether giraffe, Greenland shark, and lion occurs within our animals vector. And then we have an object called animal to check. And we always ask whether this vector occurs within any of this, right? So if we do this, then giraffe occurs and lion occurs, as we've seen earlier, within each part of the element. So the first element was a Greenland shark, and then if you go further along, that's where the lion is as well. I see someone's raising their hand.
Hi, yes, I had a quick question. The last output here, even though we have so many animals in the input, the output is pertained to only 7 to 8 Boolean values. So is that something that is common? Like, how do we get the Boolean values for all of the inputs?
So what you're doing is, so this is essentially referring to the animals vector, right? Because if we run this animals vector on top, right? You can see that the first value is Greenland shark, right? And Greenland shark does occur in here, right? So that's why this number, this length of the vector is referring to the length of the animals vector, right? It doesn't refer to the length of each of the logical tests, for example, right?
Well, sorry, I was referring to the length of the next one, the next output that we were checking. That has a very pertained, like, I feel like there would be more Boolean values here, wouldn't it?
No, it would be the same length as animals. It's always referring to the length of animals, right?
But then we're kind of checking when we're verifying with the percentage in percentage operator as well. In the second portion, we are kind of putting all the animals in one set, concatenating them, and then checking it.
Yeah.
And checking for a larger set of animals as well. So why would the output be the same number?
Because essentially it refers to the one that's on the left here. We could do the other way around, right? We could say, if we run it the other way around like this, so it's always checking what's on the, like, check what's the thing that's on the right side, check whether it occurs what's in the left side, right? Which is not ideal because you're not reading, you want to read from left to right, but in this case, you're reading right to left in a way. Do the animals occur in animals to check, right? And animals to check, remember, we created 3 animals here, right?
Correct.
So animals to check is a number of 3, the length of 3, and that's why the output is 3. If we do it the other way around, then the output is the length of whatever is on the left side, right?
So this will only go on till, for example, we've gotten our 3 true values. Because so my question basically is that I got your point about how it checks the values on the right, but when we are writing animals to check, we have quite a large list of animals, right?
Yeah.
And when we say animals, those were the 3 particular animals that we had selected. So if we are checking that animals to check has animals, shouldn't it kind of show us the entire list of falses and trues, or will it end at the 3 trues?
It will not show the entire list, right? It will not show, like, I think you're referring to whether it says, does honeybee occur, yes or no? Does this one occur, yes or no? That's just not the way it works, I suppose, right? Well, if you would want to do it for each individually, right, you can do that, right? You can do that with not the in operator. You would just do this, right? Honeybee.
But is there like a quick way to do this? For example, if I were to check if I have a set of 100 animals and I want to check if 50 of them are present in that 100, and I don't do it one by one, then how exactly would I figure my way out?
That is how you would do it then. You would do it this way. So you have this entire list of animals, and then you would do this operation here, and then you could check whether any of these animals occur within your animals vector. And I think it's going to be clear in 1 second when we talk about indexing, I think, right? Because this whole thing is now leading towards indexing your vectors, right? I hope it's going to be clear in the next thing. Okay?
Okay, makes sense. Thank you.
All right. Okay, so indexing. So why am I even showing a logical test, right? You could say like, why am I checking whether something is true or false? It's going to become very clear now, because now we can actually filter down our objects based on these logical tests, right? And hopefully it's also going to answer your question a bit further. Because as I've told you earlier, indexing starts with 1. in R, right? And if we want to index in R, we will use a vector, and then we use square brackets. And those square brackets, within them, we tell it the number that we want to keep within the index. So you can say that the vector starts with 1, the first element is 1, right? The second element is 2, and the third element is 3, and so on, right? So if we want only the first element of the animal lifespans, then we will within the square brackets write 1, and that gives us the first value of an animal lifespans, right? So just to show that it's true, if we run animal lifespans, we see the first value of an animal lifespans is 392, right? So this is how we can retrieve a single value from a vector. And if we get the first value from animals, that's Greenland shark, right? So this 392 refers to the Greenland shark, right? And now we can also use the fifth element, right? We can extract the fifth element and so on. And that's the lifespan for a fly, because that's the names, and that's the lifespans that we created, right? We can also use vectors for indexing, right? So if we want multiple values, then we can use a vector within these square brackets, and that gives us the first, the third, and the fifth elements. So Greenland shark, tortoise, and fly. Okay, so you can index by numbers. I think it's pretty straightforward, but you can also index with these logical tests. And I hope this is where it will go into answering your questions as well, and why logical tests are also so powerful, right? So instead of specifying the actual index of where the element is that you want to retrieve, you can also give it a true or false, and it will keep all the elements where it's true and remove all the elements where it's false. So let's do a logical test again with some values. So we want to ask, for example, which of the animal lifespans are longer than human lifespans. That gives us this vector of true and falses, right? But this vector of true and falses is by itself not super useful, because now we know the first value is longer, right? But what is the first value also, right? Because we've also created a vector of animals, which is the exact same order as the animal lifespans, we can now index it such that we can say, for all the values where animal lifespans is longer than human lifespan, give me only this within the animals, right? And so now we can ask, which are the animals that have longer lifespans than humans, essentially, with this code, right? And that's the Greenland shark and the tortoise. And this relates to the first and the third index within this object, right? So this is the same, this is the same as writing this, right? You're getting the first and the third element, Greenland shark and the tortoise, but you might not know where those are, right? And you might actually are not really interested even in where in your vector these two animals are. You just want to know all the animals that have longer lifespans than humans, right? And now let's say I only want to keep certain animals within my animals lifespans data set, right? So now I could say everything that is within my vector of 1, well, let's see, it's not with numbers, it's not ideal, but we can do it with not numbers. So we could say, let's only keep Greenland shark and what other animal is in there? Is the cat in there? And cat's in there. Well, maybe it's not, but that's fine, right? So basically I'm saying within my animals vector, only keep those that evaluate to true if Greenland shark and cat are in there, right? So that's how you could check in your vector if any of these animals occur, and keep them as well, right? So rather than just having this true false output, you're getting the actual filtered down vector. Okay, I hope that is clear, and there's going to be some exercises later where you can try it out a bit, and then we're going to also go over the solutions together, and hopefully that will make it clearer as well. But if it's not entirely clear to you right now, it's also totally okay, because it just takes a little bit of practice as well. Sorry?
Sir, I have one question.
Yeah.
That how many months of practice it would take to master on this R programming?
Sorry, I think you're cutting off a bit. I'm sure. Maybe you can write it in chat or something, because
Okay, okay,
sure. Yeah, sorry. Sorry about that. Okay. All right. So we will move on to a slightly more complicated topic, which is functions. And we're also going to create our own functions in this process, but I hope that I can explain it to you in a way that is also hopefully fun as well to you. So remember when I said everything that exists in R is an object? Well, everything that happens in R, you can say, is a function. And a function you can imagine as a little machine. And this machine takes some kind of input, processes that input, and then creates some output. And everything that goes into a functions, you can say, are arguments. And these are sort of like the predetermined inputs. So in a machine, you can imagine there's some input, there's some numpads where you type in numbers. There's a lever where you can do up or down. So there's some kind of way to input values into your machine. And these values are numbers, for example, or the lever and so on. That being on or off, a Boolean or logical, for example, right? So I will show you an example of a function, and I'll call this function the star producer. And the star producer has one purpose, and it's creating stars, right? So you can imagine the function name of, and we've already seen some of these functions, right? But here we're going to really explain what they do and how they work, right? So a star producer takes two arguments, the how many and type, and the values that it expects is a numeric value for how many, right? It wants to say how many stars do you create, and also what kind of stars should it create. And that in this case is a character vector saying squiggly, right? It should create squiggly stars, and it should create 13 of them. And notice that you should really look for what kind of input your machine expects, right? You can't put a character vector into how many, because it's a number, right? So functions typically in R expect you to provide them with a particular type of values as well. Now, there's a lot of functions in R, and it's always a bit confusing how they work, because everyone that creates them maybe has a bit less or different kinds of expectations about how they should work. But the good thing about R is that there's always a way to get help right within those functions. Typically, people also create documentation for functions, and they're directly available within R. So in order to get help, we could run the following code. So we do a question mark, and then we use a function. So for example, question mark sequence, which is a function that creates a sequence of numbers. If I run this code, it actually brings up the documentation right within RStudio, which I think is really useful and really can help with getting to know a function really quick, right? And so there's a general description, there's some kind of usage of it as well, and also it has all the arguments for the function. And if you scroll all the way to the bottom, there's a lot of information about them. There's always some examples as well, which tells you how ideally the function should be used, which again is something that I find really useful, and you should always check out before you use the new functions, how the author of the function intends it for you to use. Now the sequence functions has 3 relevant arguments for this. I would say from, so from where should the sequence start, to which number should the sequence go, and by, so the number of the increments by which it should go. For example, by 2, so it's like 1, 3, 5, and so on, right? Now, if we use this function within our machine idea, now we have the function name, we have the arguments, the from, to, and by, and then we have the values, which ideally should be numbers, right? So it's 1, And here we want to create a sequence of 1 to 10 by increments of 1, right? So we plug in 2 numeric values, or actually it's 3, but there wasn't any space. We plug in 3 numerical values in our numpads, and that creates an output of 1 to 10. Okay, so if we actually then apply this function in R, so we have the sequence and say from equals 1, 2 equals 10 by 1, we create this vector that goes from 1 to 10, right? And you notice how I actually named which value belongs to which argument, right? And that is always a safe way to do it. And to pass these values, so it's called passing values, you can do that by these names, as we did before, but you can also pass them by position. So what does passing by position means? Well, essentially, whatever order the function arguments are defined in, you can just pass those numbers to these functions, right? So what also works instead of just doing this is I can say 1, 10, and 1, right? I don't specify what the names are of the argument, and I run this, and it works just the same. Why? Because if you look at the help file, and these 3 dots are actually just a placeholder, essentially, so we can ignore this one. But the 3 first arguments are from, to, and by. So it just will match by position. 1, 10, and 1 refers to from, to, and by. One other thing you can do is you can change the order of the named arguments. So you can say 2 equals 1, by equals 1, from 1. It's not necessarily recommended to do it this way in this case, because that is not really as readable as the other way around, but you can also do it, right? You can change the order, but then you have to specifically name the arguments, because otherwise you wouldn't know where to put them, right? Okay, so passing by name or passing by position. So remember, if there's no names specified, like no arguments specified, then it's probably because it's being matched by position. And a lot of functions are made so that the positions make sense, right? So you don't have to always write out all the individual argument names. Okay, so some more examples of functions. So here we can do some statistics, for example. So you can calculate the mean of the animal lifespan. So the average animal lifespans of the objects that we created was 94. And it is actually because there's some huge outliers here, right? So if you're familiar with how the mean works, it's actually driven by outliers. So if we, for example, look at the median, which gives us the number of which half of all the animals are below and half of which all the animals are above this animal lifespan, it's 27, right? So that's a much more robust way to estimate sort of the typical animal lifespan within this vector. Okay. So you will encounter a lot of these functions as we use R, right? So we now did a lot of logical tests and so on, but now we really go into the workhorses of R in a way, I would say. Now we will create our own functions. And I think it's really relevant to be able to create your own functions. There's a lot of functions out there, but once you create your own functions, you understand what the limitations and applications of them are. So in order to create a new function, you would define the function name, which is here. Oh, I should click on it. And then you would define some of the arguments. And then within curly brackets, you have the function body. So everything that's within here is something that is executed within the function itself. So here we would have the argument, it assigns it to value, and then returns a value as well, right? So, sorry, I should say this function is always called function. The function name is the object that you're going to create. And here are the arguments for your function. So let's just create a new function called square. And this function is created in a way I showed you earlier. So essentially, this is the function call that creates a function. And this is the process that named it, right? So we're going to create a function called square, which creates a function that squares. The input of that function we define as number, could be squared, but it could be any other name, right? So this is just a variable name that we're going to use within the function body itself. So now we're going to use this curly brackets, and within it, we're gonna have the number to be squared, and this is the exponentiate logic or operator, and we're gonna exponentiate by 2, right? And then assign this to squared number and return the squared number, right? So what this function does is use any number that comes in here, square it, assign it to squared number, and return the squared number. It's pretty straightforward. And now we just created a function that squares. So we put in 4, and notice we don't name the argument because there's only 1, right? So it immediately knows this is the number to be squared. And it's 16, right? So we can also put in 2, and that would be 4, right? If we put in a character vector, that won't work, right? Because it's not a numeric variable. And you don't technically have to define the return. If you just have it as the last thing that happens in the function, it will also work, right? But it's a bit more tidier if you do it with the return, because the return tells you that that's where the function is supposed to end, essentially. So we're gonna do it in good practice and include the return here as well. Now, let's get to the dog to human years function. So we did earlier calculate the conversion ratios of various lifespans, and now we want to create a function that does exactly that. So we're going to define an input, and we say that's the animal years. We're going to have some variables within the function that define how long a human lifespan is and how long a dog lifespan is. We're going to calculate the ratio between human lifespan and dog lifespan, assign it to ratio, and then do a multiplication with the number of animal years. So we can always know how many animal years you have in human years, essentially, right? And then it returns the human years, right? So if we want to know, for example, how old is a dog in an 8-year-old dog in human years, let's run this. It gives us the 40, right? So that's the calculation that we did earlier, but as a function. Now this function here is actually not the best way to do it, because within it, we are defining these new objects that essentially we've also already created outside of it, right? And also maybe we want to make it so that we could calculate it for any animal as well. So one way to do it, for example, is define a few more arguments, right? So we could say, rather than just having the animal years, we could say H life and D life, which stands for human lifespan and dog lifespan. And then we can use those arguments instead of the things that we create inside. It only means, if we do it this way, that the argument H life is missing with no default, right? So we have not specified what the human lifespan is or what the dog lifespan is in this case either. So it doesn't know how to do the calculation. So we have to pass it free arguments, right? So we have to pass it the human lifespan, and we have to pass it the dog lifespan. So now it does the calculation, right? And remember how it said there was no default? Well, you can also define within here a default for your function, right? So you could say, well, the human lifespan is likely not to change immediately, right? And the D lifespan neither does that, right? So you can specify a default value for these functions. And if you run it this way and do not include the human lifespan or the dog lifespan, it will immediately know these are the default values. But you can also overwrite the default values as soon as new ones come in. Let's say we find some human that for some reason lives until 200 years old, right? Then we would have a different calculation for the human, the dog to human years, right? And then you can override these default values. And it's also something that maybe guides the person using your function as well. And some people ask what function is useful for. It's kind of like shortcuts, right? So if you want to rerun the same code all over again, right? So you want to calculate the animal to human conversion ratio for a lot of different animals. You can do it by just calculating for each one of them, or you create a function where you can input the values and it outputs you the different conversion ratios, right? So it's kind of like a shortcut. It makes your code shorter and easier to read. And sometimes it's so much more complex if you would write it out all yourself, that a function really helps you with readability and what understanding what you are doing, but also for other people understanding what you are doing. Okay, let's talk about a quick note on errors and debugging. So I already saw in chat that there's been people having errors and you know, they're trying to debug. And unfortunately, I think like errors are a part of programming. It's what you will always encounter. So it's simply part of life. And I also get frustrated sometimes because it's just, you know, you want to do something and then the program doesn't let you do what you want to do it. And unfortunately, it takes a little bit of perseverance, I suppose, a little bit. But there's also some things that can help you in the process of having errors and debugging. And I want to tell you a bit of the ways in which you can essentially debug your code. So you encountered an error, right? So this is an error. Object of type closure is not subsettable is kind of like a famous error in R that no one really knows what it means. And unfortunately, R also suffers from the disease that some of the error messages really are not telling you what's going on, right? So ideally, they would tell you like exactly what's going wrong, but a lot of times they don't. Sometimes they do, but sometimes they really don't. And it takes a little bit of experience understanding what's going on. So if you countered an errors, one first thing you can do is try to understand what it says, right? That will not always get you super far, but maybe it has a clue in there. For example, we saw already an error where it said is not numeric or something, right? That might give you a clue that you try to perform a mathematical operation on a character string rather than on a number, right? If it doesn't help to understand what the error means, and again, that might occur quite often, then you can try to Google it, right? You can search for the error and also trying to search for what you were trying to do, right? So if you're trying to calculate the mean or something like that, you can search for how to calculate mean in R or something like that, right? Search the error message or search what you were trying to do. Searching the error can be useful, but not always, because there's a lot of different things that can cause your error, right? So maybe searching for what you were trying to do is the more successful way to do it. If you were running a function specifically, and then you got an error, then maybe checking the documentation of the function would help, right? So maybe you were trying to pass it a character vector where it expects a numeric, or the other way around, right? So really doing the question mark function name can help you with that. Then you can also ask for help, right? So I already mentioned that R has a really active community, and I've been making use of it all the time as well, where I'm just like posting into the world, sort of, hey, I got this error, I don't know what to do, please help me, sort of, right? And typically there are people, you know, that take the time to actually help you, and I think that's a great thing about this community. And there's free places where you can find it, I would say, on Stack Overflow. You can find them on Twitter or X, I suppose. And there's also other platforms where you might find them as well. But there's also the RStudio community forums, which I think actually are called Posit community forums now because they changed their company name. So Posit community forum is where you particularly find a only R dedicated forum. In order for people to help you, though, it is advisable to create a reproducible example. And what is a reproducible example? It's basically the minimum requirements for your error to be reproduced, right? So you are saying, for example, you want to calculate the mean. So you give them some example values that you use, right? Let's actually try this real quick because I think it's quite important, right? So let's say you're calculating, oops, so here's the function, calculating the mean. And you know, you have some values and it's this, right? So like this. So we have some values. Now I'm using the equal sign because on this keyboard, I don't know where the greater sign is right now, but it also works, right? So want to calculate the mean of values, right? And it gives me an error, right? Actually, interesting. Actually, it's interesting. It gives me an A, because in this case, it should not do that. Well, I guess the mean value just gives you an A if it can't calculate it, right? But it doesn't calculate the mean as you want it to, right? Why doesn't it do that? Because there's some kind of character in here, right? So ideally, you would copy paste each step that you're doing that reproduces the error, right? So this, in this case, this is all the steps that there are that reproduces the kind of thing that you wanted to do, and it didn't work out the way you did, right? And now someone in a forum would immediately be able to tell you, well, there's something weird here. Like, why is there a character in your vector, right? So you run this, and then they would say, you know, you can actually run it this way, and that won't cause an error for you, right? So try to tell them the minimum amount of code that is required to reproduce whatever error you're creating, and keep it as easy and simple as possible. And oftentimes, if you're going through this process, you'll actually find that you're going to discover what the error was yourself, right? So that's another added example, added benefit of using reproducible examples, actually. Okay, and finally, I do want to mention that you can ask large language models for help, and I personally also do it all the time, so there's no like shame or something in doing that. I would just be advising you to use them with caution, as in actually any use of them for if you use large language models for anything, you should use them with caution, with reasonability, I would say, because sometimes they just produce code that doesn't work, right? Or maybe it even produces code that doesn't even like produces something, but it doesn't produce the thing that you wanted it to do, but you never really know because you didn't understand what it was doing, right? So really try to be careful when using them. But having said that, they can be an extremely powerful tool for helping you debug things, right? And you would do similar things as I've done right now, right? So give them, for example, a minimal example of what you're trying to do, describe, copy paste the error message that you're getting, copy paste the data set that you have, if the data set is not any like, you know, personal data or something like that, of course, right? But, or even copy paste an example of your data set, right? And then say, I want to perform the following operation on or something like that. And I use it like this all the time, and it works under certain circumstances, and you have to interrogate it a little bit. And that would be my advice for LLMs. And if it all doesn't work, it's also okay. Just take a break, come back later. Sometimes you get the epiphany while taking a shower. It's something that occurs to me all the time as well. So that is also totally fair. And I hope, yeah, errors is something that is normal. It occurs all the time. It happened to me while we're having this conversation as well. So don't worry too much about it. Okay, so we're good in time to do some exercises. So I talked a lot now about how to use R and the various functions to essentially what constitutes base R, like the things that R is being shipped with from the right beginning, the very fundamentals of R. And now I want you to try out some of these. These exercises will be done within the next 15 minutes. And we'll see how far you get. If you don't get all the way through it, that's also totally fine. Then, yeah, then we'll just go through the solutions together at the end of it. And I want you to open the 02 exercises 1.rmd. And if you go to files, you can also, for example, click on this one. And that has a bunch of tasks for you. And these tasks should be easily solvable for you based on what's within all the material in 01R basics. So it has nothing really new. It's just applying and trying out things. And again, if you encounter errors, try to follow the sort of script that I gave you, but you can also ask, of course, in chat as well. So I would say, yeah, the next 15 minutes, try to do this. And I wish you great success. Yeah, Inga. I mean, I will reply to some questions, I think, as well, as people are working on it. I think already someone gave you the solution, Inga. You wrote mouse equals hamster, but the equal sign is, of course, assignment in R. So you assign the hamster value to mouse. So if we want to test the equality between, yeah, you are showing the thumbs up. I see you. All right, you got it. Well, it's, again, don't worry. I mean, stuff like this happens to me too. It does really happen. I have 10 years experience, so it's not something, it just happens. And then, you know, you talk about it and then you move on. You don't have to submit exercises anywhere. No, this is just for you in your own time. Because I mean, I talked a lot about how to do things, but it's really important that you're trying out and figuring out things yourself as well, because that's how you learn, right? Yes. Lucy, if your layout pictures are not loading, you might have to click on visual. So there's like a source mode and there's a visual mode. And that's where the images and so on are in there. That should ideally display the layout as well. All right. I see hands up. Yes, please.
So I had a question.
Yeah.
So like in Python, when we kind of write the if-then statement,
Yeah.
do we have something that we can use similar to R, similar in R? Because like in task 2 of this assignment, it says compare the lifespans between the chosen animal lifespans and whether the output makes sense. So if we write something like how can we substitute the if this condition is true and this condition is true, then print this.
Yeah.
I'm in a very Python sense right now, but just trying to understand how I can apply that in R.
Yeah. So there is if and else in R as well. There is a direct equivalent to it. I can show it to you, but I think for task 2, you don't have to do it that way. For task 2, you just have to very simply compare one object with the other with the logical operators that I've shown you before. So that, for example, is the equals or the greater than and so on. So you don't have to say if and else. You can just use a specific logical operator for that. Does that make sense?
Yeah, for sure. Thanks.
Okay. And I'll write into chat how if else works in R, just that you have that for reference as well.
And one more question. Can we also like get a statement printed? For example, if I did the entire thing and then I can just write the statement. So could that be done as well?
Sorry, can you repeat what you want to do in the end?
So like, for example, if I compare the two variables and then I know what the output is going to be. So can we use a print statement and kind of write Can I use like just print for that?
You can just use print, like you can use the function print, open brackets, and then output the object that you created, for example, or you can just literally just run the code and that will also output it, right? So print actually doesn't add much here, but you could print it as well. Yeah.
Oh, perfect. Thanks.
Yeah.
Hello, teacher.
Hi.
Hello, I have a question. As I found that if I type something like dogs, and it can identify it, but if I type something like dog life spine,
Yeah.
I mean, it don't have the S, and it will not identify it. So I'd like to ask whether we defined something in the R Studio, and then it will memorize it, and do not make something just a little different to understand. The R Studio will not understand the little difference, right?
Yeah, so I mean, you would have to create an object and reference it in the same way that you created it, right? Like if it's dog lifespan, then you would have to, if you create an object called dog lifespan, then you would have to always reference it as dog lifespan. And if you write it slightly different, it cannot recognize that that is the object that you created, right? So it's very sensitive to the way you've created the object, right? So it doesn't also work if you have an uppercase versus lowercase and so on, right? So
okay, thank you.
Yeah. Okay. Okay. Just two more questions. So the error in load namespace is actually a very tricky error. It means that something of your packages are wrong, like something's not being loaded correctly. So there's multiple ways to try to fix it. It's restart R is always the first thing to do. Then trying it again. If that doesn't work, removing all your packages and reinstalling them, or removing the xfun package in particular. Unfortunately, this one is a bit tricky to resolve, but try to restart your R first. That might help. Okay. Then there's a question, and I'll take one more question, and then we'll go for the results together, or the solutions. Yes?
Yes, hi. So with the error in load namespace, I just updated all my packages. And for some reason, I don't know, would I have to uninstall all of them, or just, like you said, maybe restart? I'll try restarting R.
Yeah.
But I am somewhat familiar with R, and this is an error that I've not ever got, basically, to this point here.
Yeah. Okay. Well, it's a super annoying error, and it's good that you didn't get it so far. if restarting R doesn't work, you might have to start removing some of the packages. Try with the xfun, because like xfun is the package apparently that causes some errors. So maybe you have to reinstall it.
Okay, because it's showing something called bad exception. There's like an little error window that pops up when I try installing that particular package. xfun.
Yeah, there must be something with it. Unfortunately, it's sometimes this is like unfortunately part of it sometimes, right? But I hope you can resolve it. And if not, there are these other options, right? There's Google Colab and Binder to help you along if it doesn't work out for the rest of the course.
Right. Okay. Thank you.
Okay. So let's go for some solutions, and you will also get those solutions at the end as well, so you can compare it. But so the task one asks you to pick 3 animals and then assign those some lifespan values, but also some appropriate names, right? So here I picked giraffe, penguin, and elephant, right, from this table up here, and essentially just gave them specific names, right? Task 2 is creating some logical tests which compare the maximum longevity between them. So, for example, is the giraffe lifespan the same as the penguin lifespan? That's false, because the giraffe lifespan is, where is it? 39.5, and the penguin is, penguin's 26, right? So it's not the same, and so on, right? So basically, I just wanted you to do some of these logical tests yourself. Just be creative in like maybe comparing them. And if I ask you, does the output make sense? Just to double check whether, you know, is it actually the same, or is it different, or is it bigger or smaller, and so on, right? So in each of these cases, that's how you might be able to solve them, right? Here's giraffe lifespan is bigger than penguin lifespan, that's true. And elephant lifespan is not the same as the penguin lifespan, right? Okay, so the task 3 is asking you to create 2 vectors with concatenate. So one should be the strings or the texts, which have the animal names essentially, and the other has the respective lifespan values in the same order, so we can actually like perform some tests, for example, later on as well. So we create 2 vectors. One is called the animals of the giraffe, and one vector called lifespans, which has all the lifespans in the same order as well. And we've already created the objects for the lifespans as well. So now you should calculate the mean of the lifespan vector. So in this case, it's 40. Task 5 asks you to retrieve the second value of the vector. And remember, with R, you index by 1, right? So it's 1 and then 2. You retrieve the second index from the animals, and that's penguin. Now, this one asks you to look at all the animals that are above a lifespan of 25, right? So now we're doing some indexing by a logical test, right? So to filter down sort of the data set. And in this case, I selected animals that are all above 25, right? So if I do the lifespans above 25 within here, and remember, like this one would actually give me true, 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 because each of these lifespans is above 25. So if I index it, each animal will be retained, right? Because it's all 3 of them are true, right? If the third one would be false, then it would only be giraffe and penguin, for example. Now, calculate the animal to human conversion ratios. Remember that the maximum lifespan of a human was 122.5, and then we divide that by the 3 lifespans and have the conversions within an object. And then task 7 asks you to convert, to find how old these animals are when they're 5 years in their own age range versus in human years, right? So a giraffe that is 5 years old is 20 in human years. A penguin that is 5 years old is 23 in human years, and an elephant in human years is only 9 if they're 5 years old. Okay, and then finally, creating a function that's very similar to what I already had. So I was trying to really create you or provide you with basis of creating a function that you had to. There was a lot of there already in the script, I would say. But yeah, so you should create this animal, the penguin to human years function, for example, whatever your animal was, and then just do the exactly same thing essentially that I already showed you. And here we create, we apply the 5-year penguin, and we find that the penguin is if it's 5 years old, it's 23 years in human years, right? Okay, so don't worry too much about whether you got all of this right or some of it is confusing. I will provide you with the solutions at the end. And I'll look at the chat real quick. Okay, all right. All right, so let's see. So we're a bit early. So I think what we can do is maybe jump ahead a little bit. Let me see. Now I have a lag. So now we can talk about data frames real quick, and we get go into the break in like 8 minutes or so. So that we can pause on time. So data frames. Now we looked at vectors, we looked at individual objects which hold one value, but in data science, mostly we want to deal with data frames because that is the essential way where we can apply our models on, for example. So we already saw data frames when we looked at the table, for example. So this animal and maximum longevity table essentially is a data set because each row has, for example, there's a human, and then that is 122.5 is its maximum longevity, right? So we have 2 columns and each row, and that essentially is a data frame then. And in order to create a data frame within R, we could use 2 vectors that are the same length. So somewhere here we created an animals vector, which has a bunch of different animal names. And we have the animal lifespans, which has all their lifespans. And if we create, or if we use the function called data.frame, then it will create this data frame and also assign it to animals data. It looks like this, right? So there's each row, there's 2 columns, and each value corresponds to the animals. And notice this only works though, because animals and lifespans have the same length, we created it this way, and also in the same order, right? If this animal lifespans vector would be in a different order, well, then they would also be assigned wrongly here to each animal, right? So this is only if we create the vectors in the right way. But this is also to showcase the data frame is really just 2 vectors that are below each other. And please don't write on the thing. But yeah, okay, thank you. Okay. So within a data frame, there's variable names. So to be able to access the columns within the data frame, right? And if you use the function names, we can actually retrieve those variable names. So animals data, again, was the data set we created. And then there's 2 variable names in there. There's animals and animal lifespans. Why are these particular 2 variable names? Well, because that's what the vectors were called initially. And R here is smart enough to just take over the vector names, the vector object names as the variable names as well. Yes, data frame is a function. Yes, exactly. So why do we want to know the names of the variables of the columns within our data set? Well, because we can index them this way, right? So we can actually refer to individual variables within our data set. And we do that in R with a $sign, right? So the structure is essentially like this. So you have data set, whatever your data set name is, and then you do $, whatever the name of your variable is, right? So you can think of the $sign as kind of a door opener that helps you check what is inside a data frame object, right? So if you do animals data dollar, animal lifespan, well, that is just the vector again of all the animal lifespans. And animals data dollar animals is just the vector of all the animals, right? So that's exactly like the parts of which it already was created of in a way, right? And actually, let me go to R for this because there's something important I can show you. So the cool thing is, actually run all of this real quick. Let's do this. Animals data. And so now we have this animals data. So within R, so actually within R Markdown, there's a really nice output also as a table, which I find really useful to look at. That's something that was tricky for me when I made the switch from SPSS to R. I did learn SPSS in the beginning. I couldn't see the data all the time, but within R Markdown, you can also always output this table right underneath your chunk, which I think is super useful. You just run any data set and it immediately shows this this nice format of your data as well, which yeah, I think is super useful when you code. So if you do the $sign, a cool thing within RStudio is it actually shows you what the variable names are within your data set, right? So you don't have to like remember necessarily. You don't have to do the names animal data. Well, now we know what the variable names are, but ideally, if you type in animals data and you do $sign, it will show you what the variables are within the data set. So that's really easy then to access. And if you click enter, you don't even have to type it out, right? So coders are lazy. I'm not sure if I mentioned that before, but coders are lazy. So this is a really nice way to autocomplete and not have to specifically remember all the variable names you have in there. Okay. Let's remove those. And by the way, because I switched back into this is a zero-free data manipulation.rmd. So this is stuff that I wanted to do after the break, essentially, but we're moving already into this. So it's zero-free data manipulation.rmd. And make sure that you run all of this code that's before. So just that you have all the objects in your environment. I keep the environment here on the right. Oh, by the way, now you can see like the data set also has its own entry in the environment pane as well, right? And there you can see it's 9 observations. We have 9 animals in there with 2 variables, right? So there's also like a nice overview of what kind of data you have loaded in your environment, right? Yes, it is the index, right? So basically 1 is the Greenland shark, and it's 1, 2, 3, 4, 5. 5 is the fly, 6, 7, 8, 9, 9 is the human, right? So that is the index. It's a bit messed up sometimes. It looks a bit odd, right? But that's how it works. Yeah. Okay. So as we like seen, a data frame is essentially 2-dimensional, right? So it has a number of columns and it has a number of rows. So with the function ncol, we could check how many columns does a data set have, right? In this case, it has 2. With the function nrow, we can check how many rows it has, right? And that can be useful sometimes to double check, you know, if you have 500 participants or something like that, you want to know whether your data set actually has 500 participants and you want to, you know, conduct a test or something where that actually is the case. You could do that with these functions. There's also dim, which gets both of these informations in the same call, right? So dim gives you as a first, the output is a vector, and the first element of the vector is the number of rows, and the second output is the number of columns, right? Okay. So we talked about how to retrieve variable names, and indexing we'll do after the break. So we'll just talk about coding variables. So if we want to create a new variable within a data frame, which is something that we have to do all the time. Let's say we want to create the conversion ratios for each of the animals in our data set, right? So we have the animal lifespans, and we have to divide that by the human lifespans. Actually, it's the other way around. Let me actually do that. Okay. human lifespan divided by animal lifespans, right? So because this is the same as just having the vector, right? It's the same as calculating human lifespans by this vector. Now we're just retrieving it from the data set itself, right? And that gives us all the animal to human conversion year ratios, right? If we want to have this value in our data set, this variable in our data set, we can just assign it lifespan. Okay, now I'm jumping around it. Because yes. Okay. Not enough space. All right. So the way we create a new variable then is to assign it into a variable called animal to human, for example, right? But this animal to human variable does currently not exist, right? We saw that there's two, if you run this names animals data, we saw that there's two variables within our data set, animals and animal lifespans, but there's no animal to human variable in the data set, right? So if I run this, it actually gives us null because it doesn't exist, right? Null is another placeholder for it doesn't exist, right? So it doesn't currently exist, but if we assign this value into it, it creates it, right? So that's how you can imagine, or that's how you can remember how to create a variable, is just you assign it into a new variable name. And this could be anything, right? This could be X, O, whatever I just wrote, right? And now there's a variable called XXO, right? With all these values in there. That's not essentially what we wanted to do. We wanted to create a variable animal to human. So if you run this again, there's an animal to human conversion ratio within this. And now there's 4 columns, and we kind of want to get rid of this, but I'm going to make this a spoiler because now we're at 2 p.m. Central Eastern European time. And I want to give you 15 minutes of a break because it's been a lot of stuff. And I hope you can relax a bit in these 15 minutes. And we're going to meet at 2:15 in Central European Standard Time. And unfortunately, I can't do these calculations in my head because I'm a coder and not a mathematician. So whatever is in your time zone. Okay. Then see each other in a bit.
Anywhere you go, you belong. Anywhere you say, anywhere.
not exactly time yet, but I will just mention a few things that just came up. For example, using our Markdown, which I think is a choice in this case. For me, it's a choice, but I think it is valuable because, so example, one thing that I do in my work, for example, is I create dashboards all the time to sort of visualize the kind of things I'm doing in R, right? So here's, for example, a dashboard that I've conducted created for the 2023 Greek election, where I'm looking at how political parties are using micro-targeting on meta platforms. And this entire dashboard is created within the framework of our Markdown, right? So all of these graphs, you can see all of these individual, even interactive kind of aspects, so you can create maps and so on. This is all within the framework that we are using R in today, right? So for me, it's a really nice way to write code and mix it with text, right? Because when you write raw R, you have to use these comments and so on, and then you always have to make sure that you don't mess up sort of the writing of your code while also maybe documenting it at the same time. Whereas our Markdown provides you with the infrastructure to mix the text part with the code part in a way that is separate as well and readable, and easily translates into these kind of dashboards, but also reports and so on. So for me, it's a really powerful tool to do data science within these notebooks, but I also realize that it might not be something for everyone. And also, it's totally fine if you use just R scripts, right? For me, it's just then if I use just R scripts, there's another step for me to then create these dashboards or something on top of it, right? So it's a way of preference in a little bit. So we're doing it this way today, but there's also value in not doing it this way, I would say as well. Okay, so to confirm that you are all here, I want you to do another Menti, just to see that everyone's back here. So if you would type in this code here, and actually, let me copy paste it in here into the chat, just to see that everyone's back here. So here's a very important question of which animal is the cutest. And I'm sure there's other types of animals that are very cute, but there's only a selection of 5 in this case. So, so please vote. I hope this time it's working. Yeah, there was. Okay. Okay, we got a neck on neck for the doggo and the kitten. Who would have guessed that? Wait, the check marks down below mean that all the answers are correct. So this is a graded question, but all the answers are correct. I think it might be a bit slow in adapting. So I'll give you okay. Oh, we got a lead on the kitten. I hope none of you are creating or logging into VPNs to interfere with this very important poll and give multiple votes to it, which would be legitimate, I would say. Okay, let me refresh it one more time. I think it's maybe not refreshing by itself. Oh, and we got the doggo. The doggo is on top now. So, but we got a good second place in the kitten. The others are being very cute as well, and the neck on neck on the duck and the snack as well. All right, so this is just for fun, just to get you back on, get your attention back to also a very fun thing, which is data manipulation or data wrangling. The term data manipulation is somewhat odd, right? Because it implies something nefarious, but it's a typically used term in the within data science, I should say. Okay, I left you off with a cliffhanger, actually. I left you off with this weird variable that we created called XXOO, just to demonstrate that we can create new variable names just as we like. And basically, the way we could get rid of it is via indexing. So we've learned indexing before when it came to one-dimensional vectors. And now we will talk about indexing within a two-dimensional data frame. So this two-dimensional data frame works similar in a way for a vector as well. So we will have a data set. So this is the data set name. You also use square brackets, but now that it is 2 dimensions, you also have to specify 2 values of which you want to index, right? So the first value within these square brackets would be the rows that you want to index, and the second number is the columns that you want to index. So how does it look like in practice? So we have the animals data. Now we have 4 different columns and 9 rows, right? So let's say we want to only keep the first row and the first column of this data set. Then we would specify 1. This one here is for the rows, and the second one is for the columns. So row 1, column 1 is just one value, right? It's just one cell within the data set, which is Greenland shark, right? It's the first row and the first column, right? So in this case, we don't even have a data set anymore because it's just one cell that we're specifying, right? If we want to keep like a certain row within the data set, but still keep all of the columns, then we can just like leave the second value empty, right? Again, second value is for the columns, but we only want the first row. So if we run this, it gives us only the value for Greenland shark. And this will actually keep, it will keep the format of a data frame as well, right? So the first row, but all of the columns, right? And the same works for all columns. Sorry, if we want to just keep one column, but all the rows. But in this case, it also gives us a vector back, right? So the vector, again, remember like a data frame is just vectors aligned vertically next to each other, right? So if we just retrieve one column, it'll give us one of these vectors. But actually, if we retrieve two columns, it will not give us a vector. So if we want column 1 and column 2, that will actually give us a data frame with column 1 and column 2, right? This is just how it works. If you just ask for one particular column, then that will retrieve it as a vector, right? So now I'm going to solve the cliffhanger of like how to remove this column, right? So maybe someone in chat. Well, actually, no, I didn't mention it really, right? So I will explain it because we want to filter things. We could do it in two ways, right? We could say we only want 1 and 2, right? So this is these are the first two columns, right? Animals and animal lifespans. But we also really want to keep animal to human, right? So one way to do it is say, give me 1, 2, and 4, right? Because the third column is the weird one that we don't want, right? Oops, sorry. Well, there's an error. Argument free is empty. In this case, actually, argument free is empty is kind of an expressive error, I would say. So this is actually useful, right? So you can see that I did not specify a value within this vector, and other than indexing in a vector, you do have to really specify each value, right? And I didn't, so it gave me an error. If I do say 1, 2, and 4, it gives me column 1, 2, and 4 and removes the third column. Now we get rid of this weird column that I created earlier. Importantly, we didn't actually like save it this way, right? We just ran the code, right? But remember that we can assign things, right? So in this case, if I wanted these options to be permanent, right? So if I just run this particular code itself by clicking on run here, then it would still have it, right? Because I haven't saved it. So I would have to overwrite animals data for these changes to take effect, right? So we're just showing you right now how it works. But if you want to actually save it, you have to assign it. Now, before I do that, though, I want to show you a different way, which I haven't mentioned yet, to index as well. So this indexes the data frame by selecting what you want. But in our case, it might actually make more sense to select what we don't want, right? So to specify what we don't want. And a way to do that in R is by using a minus. Just use a minus. And in this case, it's the third one we don't want. So we say -3, and that gets rid of the weird column that we didn't want to have, right? So, and this actually also works for vectors, right? So let's say we want to get rid of 3 and 4. So before the vector, we put a minus, and this minus then gets rid of both the third and the fourth column as well. Okay. This so much about that, and now we're actually gonna get rid of. By the way, you can also create a single. You can create a vector with just one element, but then it's not really a vector, right? But you could do that, right? This would also work, but in this case, that's unnecessary, right? So we'll not do that. So we get rid of the third column that was weird and assign it to animals data, so that it's actually not in the data set anymore, and it doesn't bother us, because it was a weird column indeed. All right. So let's get to indexing of logical tests. So similar as we've done indexing with individual vectors, we can also do indexing of logical tests on data frames as well. So remember what we did earlier is also like we wanted to know which animal lifespans are longer than human lifespans, right? So here we would do the same thing, just that we access the animal lifespans within the data frame itself, right? And then it would give us the same vector of true and falses as before, right? So the first one I think was the Greenland shark, and the third one was the tortoise, right? So these are all the animals that are above human lifespans. But now we want to keep only the animals in the data frame that are longer than a human lifespan, right? Not just the vector. Actually, let me show you again how I would do this if I would just filter the vector. So we have the vector here, and we do square brackets. And because this is a vector, there's only one index that you give it, right? It's one-dimensional. And that gives us both of these values, right? But we want to filter it in the data frame. But it's essentially the same frame. So we have data frame, which was called animals data, remember? Actually, I'm going to output it here so you can see it. So we have 3 columns, 9 rows. And if we only want to keep the animals that have longer lifespans than humans, we would use a filtering by rows, right? But indexing by rows. And rows, of course, is the first of the 2 values within the square brackets in a data frame. Rows and columns, 2-dimensional. And because that gives us a true and false, we can index in a way that only gives us these 2 animals in the end, right? So again, this part here is true, false, and so on, based on the logical test that we provided. And it only gives us the rows where this is true and false. And this works, of course, because this is the same data set, right? And then this is the same order as well. And that's why we're indexing it correctly, because we're using the same data set to index the rows here. Okay, up until now, we really used only base R. And what is base R? Base R is what R comes with natively as you install it, right? But in practice, you won't just use base R. You will use an array of packages that you will install on your computer that will enhance your experience and make your life, honestly, much easier than what we've seen so far, right? The reason why I've shown you all of this is because it's the basics, and there are some important things here that you will have to apply as well. But honestly, there is also a lot of things here that I showed you that are actually more complex than they need to be. At least that's how I would argue it. Because R packages are tools that will enhance your R experience, I would say. So what are R packages? What is this thing that I'm telling you about? Well, R packages oftentimes are have these really cute kind of hexagons where people design them, and it's kind of like by the Boy Scouts or the Girl Scouts or something like that. You get a little hexagon if you master it. No, everyone gets one. But I think it's a really cool way to sort of establish kind of the tool sets that you might have in R. And all it really is it's a bunch of functions, and functions we already learned about, that other people have written and compiled them in individual packages, right? So for example, which one is a good one? Correlation. There's an R package called correlation, and that one creates a bunch of functions that should simplify for you to calculate correlations between 2 values, right? And they have all the documentation, they have a lot of tutorials and all the things to teach you how to perform these actions. So they can really enhance your experience. And one way to think about it is packages are kind of the tools you buy from the store, and then you have them in your little garage or something like that, and you can pull them out whenever you need them. So how exactly do you buy and pull them out on your table, for example? So you buy a package by writing install.packages, and then within quotation marks, you would write the package name. So for example, here, we would install the package janitor, right? And if you follow the pre-workshop instructions, you've already installed this package. We will need it in a second as well. Yeah, if you haven't installed it yet, now would be a time to click on this button and install it. I'm not going to click it because I already installed it. And also it says eval equals false here, by the way, which is a chunk option you can specify if you don't want it to run when you run the entire document. So for me, it's just a reminder that I should run it because I already have it. So that is how you buy how you buy sort of the tools, how you get them in your garage, right? But now you want to actually use them, right? So you want to use them in your working environment, and like the process of putting them on your table so you can use them, you can do that by library. So you are now calling them in your environment by running library, and I will do that now because I haven't loaded this package in yet. And now all the functions within janitor are actually accessible to you within your working environment. One way to access those functions, it's not something that's typically taught, but I will show you, is if you do column, it will autocomplete to all of the functions that exist within this package. And conveniently, it also has like a help file right next to it to explain to you what these functions do, right? Ideally, you don't want to like look it up here for the first time because there's all these like documentations on the websites of these functions as well, of these packages, sorry. But here's a neat little way to like find a particular function with it. And also it auto-completes, right? So there's a bunch of compare functions within this data set, this package. So if I type in com, it starts showing me, it filters down to only the functions that have that, right? So it's also a really convenient way to like, if you want to find a particular function, you don't really remember what it's called. It's kind of like a search in a way, right? So I think that's really useful as well, right? Does this part also work in Google Colab? I think it doesn't work in Google Colab, unfortunately, right? So this is like an RStudio thing. I'm not 100% positive on that. Okay, but it should work in Binder, although for some people apparently Binder doesn't load, but I hope it does for some other people as well. Okay, now let's get into the tidyverse. So the tidyverse is a huge conglomeration of R packages that are specifically meant for data wrangling, so putting the data into the right shape. And I want to put a particular focus on this because, as I mentioned before earlier as well, putting the data into the right shape is like 90% of your data science work, right? It really should not be underestimated how long it takes to clean data, to put it into the format that you really need, because data typically does not come clean. Data comes in various forms that are not very clear, actually, like who intended the way, if you like, for example, get it from Excel or any government bureaucracy that created like long sheets of Excel files that, you know, are not specifically directly applicable within data science without a lot of cleaning. And that's what I think one thing you find all the time, right? Data is often not made unfortunately, for people to actually use it. It's for people maybe to look at it or something like that, but not to programmatically interact with it. But the tidyverse suite really empowers you to clean data, and that's the idea behind the tidy in a way, right? And so what is the tidyverse? It has all the processes of what you might consider a data science workflow, right? So it has functions to import, to tidy up, to model data. There's also modeling functions here, which we're not going to focus on today, because that's just an introductory course here. Transform, and also visualize. So visualization is also part of the process. And finally, communicate, which, for example, includes things like R Markdown as well, right? So R Markdown is also part of the tidyverse, where you can create these reports and dashboards and so on, as I've already shown you. And the core principle of the tidyverse is so-called tidy data. And tidy data has three important marks. One is that every column should be a variable, every row is an observation, and every cell is a single value. And essentially, we've already seen tidy data. I really tried to get this going from the very start. So now let's observe how this data frame down here about our animal lifespan data is in fact tidy data, because we have every column is a variable, right? So every column here refers to a specific characteristic about the animal, for example, right? So every column is a variable, and every row is an observation, right? So every row here refers to, for example, a dog or a cat, and every cell is a single value, right? There's no additional values within this. There's no mix between lifespans and years ratio. There's an individual value in each cell. And the reason why we want to have a tidy data frame is because a lot of other functions rely on this data format for you to be applying it on. Or if a function maybe requires a different kind of format, it's easy to transfer it into that format. And that's really important, right? So it's kind of like a baseline kind of format for your data set that can easily be transferred in all the other ways. And the tidyverse itself also has functions that help you transfer it into the tidy style and also out of the tidy style. So one way untidy data would look like, and again, just because it's untidy doesn't mean it doesn't have its uses, right? Just the tidyverse is built upon this this particular format of data frames, right? So here we have an untidy data frame that has the following issues, which is not every row is one observation, right? So we have 2 times domestic dog, and then we have 1 time the lifespan and the ratio for each dog, and that is in 2 separate rows, right? So there's the lifespan value and there's the ratio value for each dog, and then we have that for each animal as well. So there's a kind of a duplication going on here, and this data format is useful in some contexts. It's actually called a long data frame because it's longer. It has multiple observations across rows, but it's not something that we typically want to have when we work within data, within tidy data. Another way, which is even more untidy, would be if there is multiple values within the same cell, right? So we have the lifespan and the ratio, and they should really be separate columns, right? Because otherwise, you can't perform any mathematical operations on each of these, right? Because this is essentially, even though it's numbers, it's a character string, right? Because there's 2 numbers and a space in between and the slash as well, right? So you cannot really perform numeric operations on it, which you should be able to do because these are numeric variables, right? So this is also then considered an untidy data frame. And one way to think about tidy data frames is that all tidy data sets are alike, right? They all follow the same framework, but every messy data set could be messy in its own way, right? But as I said, the tidyverse style functions are meant to guide you from these messy kind of data sets into the tidy data frame format. Yes, I think I mentioned a lot of this, and these cute drawings, by the way, I have to mention this, are by Alison Horst, and I absolutely adore her art. You should absolutely check it out if you have the time, because they're extremely motivating, I think, as well, because they visualize a lot of the things that go on while you learn art. So very great artist, I can only recommend. Okay, so I did a lot of evangelism about the tidyverse. So now I'll actually install the tidyverse and also load them. Again, this is like buying the package words from the store, and this is like putting it on the table, right? So if you haven't done this yet, this was in the pre-workshop instructions. That's one opportunity now to do it. Although this one actually will take 3 or 4 minutes or something, depending on your operating system. So do it now if you haven't done it. And then importantly, put the tools on the table by loading it with library, right? And this will just tell you a bunch of stuff that it's actually loading in all of these packages. And don't worry too much about these warnings. It always has these, and this is just because there are some default functions that it masks, but that's intended, right? So these warnings that you can see here are not anything to be worried about, I would say. By the way, another important thing actually about installing and loading, I should mention, is that you only need to install a package once, right? So you don't need to actually run this install packages every time. That's why I also have it as eval equals false. I don't even want to evaluate it every time. The only reason you want to run install packages again is if there's any update to the package, which occasionally will happen, right? But most of the time, you are fine with not updating your packages. I mean, I should update my packages a bit more often, but I've been fine with it, right? But if something doesn't work that used to work, then that's a sign that you should finally update your packages, right? So this only needs to be done once, every couple of months, say that. And this library call needs to be done, for example, at the beginning of your script, when you put all the tools on your table for then do data science with, sort of, right? Okay, so we've used the animal lifespans data, and it's been a fine data set until now, but we want to do some more data science stuff and not just look at that, basically numeric variables that we had before. So now a new data set appears, which is a data set about penguins that has been collected in Antarctica on 3 different islands. So this is like a toy data set, again, more art by Alison Horst, which has a lot of sort of characteristics about these penguins, how big their beaks are and how big their flaps are and so on. There's a lot of different kinds of information about these penguins. And now this is a more fuller data set for conducting data science on, for example, right? It's still not a really huge data set, but that's not something that we can concern ourselves with today. It's just really the basics of engaging with a multivariable data set, you could say. Okay, so there is an R package called Paramo Penguins, which includes these, like you can install this package and then load in the data set. But actually, I'm going to show you a different way to read in this data set. And you can do it via a URL. So this URL here actually goes directly to the Penguins data set. And you can read it in from the internet directly into your R environment, which I think is quite useful as well. So if you would go to this, if it would let me, which it doesn't right now. Okay, anyways, if I would go to this link, then that would be the raw CSV file, right? A CSV file is just a comma separated file, which has the Penguins data set. And then I use the function read underscore CSV, which is within the reader package. This reader package is within the tidyverse, right? And you load it in when you load in all the tidyverse packages as well. So we run this code, and then it gets it from the internet. And actually what read underscore CSV does, it guesses what the variable types are within your data set. So for example, it identifies 9 character variables, so the study name, the island of the penguin, and so on. Then there's some doubles. In this case, double is just a different word for numeric. And that has like the culmen length, which I think is the beak, the flipper length, the body mass in grams. And then there's also a date variable. It's, I think, when they lay the egg or something like that. So it also is able to recognize that. And we didn't talk about date variables yet, but date is just essentially, yeah, it's a calendar date, and there's different operations that you can perform with it as well. Okay, so if we now run this Penguins raw object that we created by reading in the data set, we can now look at the data set and see all the different variables and columns, and it looks sort of tidy, right? So like there's a penguin here. And there's a sample number, which is kind of like a unique ID, I suppose, right? And there's a species, which island they're on. Here we have the date egg, which I think is the date where they laid their egg. And then a bunch of numeric variables. By the way, here it says double underneath it, so you can know what kind of variable type it is, right? What kind of class it is. There you go. So that's how you could, for example, there's also some comments, which are more character variables, right? No blood sample obtained for sex. I'm not sure what that means. Interesting. Probably some biological term. But there's one way to look at this data set is with like printing it raw out. But there's also a cool function from the Glimpse library. Sorry, it's within the dplyr library, where you can just take a glimpse at your data. And that actually displays all of the it displays all of the variables within your data set underneath each other, right? So you don't have to click through it like I did right now. And then it's an easy way to get a quick overview of all the variables that you have in your data set, right? So it's a kind of like a very simple description of your data set. And then it shows like which it's a character and some initial values of it as well. So that's a different way to take a glimpse at the data that you have. Now, I want to talk about the R package called Janitor, because I think that's an extremely useful R package that will have a lot of knock-on effects later on, because this prepares the names and only keeps the variables that are kind of relevant for what you want to do on later. So there's also a bunch of other things that Janitor does that we're not going to look on today, but I use Janitor like literally all the time. So I really want to show it to you as well, because it's going to make your life easier. And that's what it all is about, I think, making your life easier with coding, because it's already difficult enough. So again, if you haven't installed Janitor, there's a way to do it now. But make sure you have loaded it. And one function that I use all the time is clean names. So clean names makes sure that all of the variable names in your data set are underscore and it's snake case underscore, essentially, what I showed you earlier as well, right? There's a question, so I'll take the question real quick. Yes?
Hello, I wanted to ask regarding the tidyverse before. Is it used like to delete the those that are not appropriate or something like that?
Delete what? Sorry?
Like, does it delete the variables that are not right, that are not fitting, or what does it do? Like,
no, it doesn't delete, I suppose, right? It just gives you a tool set of functions to use for data science practices, I would say, right? And some of the functions in there replace some of the raw base R functions, but we don't have to worry about them. It just replaces them within the sessions that we loaded in, but then it doesn't delete anything, I would say, right? It's all still there. Does that help?
And clean names is for just changing the name to more.
I'll explain it in a second. Yeah, I'll explain it.
Okay. Thank you very much.
And one person has a problem loading in that file. I'm just going to copy paste in case there was like this is the link for the CSV. Maybe, I don't know, maybe there was a different link there as well. Anyway, so clean names. So right now in the data set, we have these kind of weird variable names, which is like delta 15 and so on. And there's like spaces in the variable names. And that's, look, R doesn't like that. R doesn't like spaces or like weird kind of special characters within the variable names. And the reason why it doesn't like it is because it does like, because it's an object, right? An object should be a defined name. And in order for it to still recognize that there's like the spaces are part of the variable name, you have to do like these accents in front of each of the variable names, right? So R really doesn't like it. So if I run this works, right? But it wouldn't work. So remove this real quick. It wouldn't work like this, unfortunately, right? Because like, you can already see that the 15 turned, right? The 15 now is a number, right? So if I run this, it says unexpected numeric constant, because there's like a random 15 here, right? It doesn't recognize that this should actually belong together, right? So that's why you have to use these accents, but that's not a really nice way to write things down, right? So the clean names functions, and before I assign it, turns all the names into lowercase and the spaces and the underscores, right? And it does so in a very consistent manner, right? So for example, species before was uppercase, now it's lowercase species, right? Now we've seen it more, we see, for example, Kalman flipper length, millimeter, right? Where there were some brackets here as well, right? So it basically unifies and simplifies the variable names so you can call them. And it's so much more easier than dealing with like these weird accents and so on, right? So I see a lot of errors when I help people with R stuff that is related to the way variable names are called or named. And this clean names functions really helps you unify them and simplify them so you can call them easier. So this is the clean names function, and that's almost always something I do before I start doing anything with data. So now I run this and assign the cleaned penguins raw to penguins clean. And now we can take a glimpse again at the clean penguins, and it's just formatted a bit oddly, but you can see that here there's these different variables and they have different names now. Right? There's island, individual ID, and so on. So this is just a different way again to take a look. A different really useful function within Janitor is remove constant. So for example, all the values of a variable might be exactly the same, right? So they don't really hold any information. So if all the values are the same, so for example, it's all XXX and it doesn't differ by observations, then you typically wouldn't want to have that in your data set because it's just all the same, doesn't give you any more information. And one such variable in the penguins data set is region. So all the penguins are actually from the same region, right? So they're all from Anvers. So there's not a lot of reason why you would want to keep it unless you report the data or something like that. But typically, you might want to have them. And it's also the case that if you have a really large data set, you have like 2,000 variables, and where do you start looking at them? If all the values of a variable are the same, then you might just want to remove them, right? And you can do that with remove constant. So remove constant is a function within Janitor. And here I also give it the argument quiet equals false, which is just basically tells me which variables it's removing, which is also really useful then. And it gives it here, remove 2 constant columns of 17 columns total. Remove region and stage, right? So we knew region already is a variable that only has 1 value. It has also stage. And if we look at that, it's also always adult 1x stage, right? So that really doesn't give us much more information, right? So this remove constant then removes these specific columns from the data set, so they're not here anymore. And it really take shape, we want to then reassign penguins clean to a penguins clean data set. What does the tables function do? Good question. I didn't explain. Table just basically counts a certain variable in your data set, right? Or it could be also a vector actually in this case. But for example, there's sex here, I think as well. Yes. So for example, if I do table with sex, then it tells me 165 penguins are female and 168 penguins are male, right? So table is just a way to count the number of observations by some other variable, for example, right? And we will learn a different tidyverse function in a second as well, but I haven't shown it yet, but that's what table does. Okay. By the way, another thing I should mention about tidyverse style functions is the data set always comes first, right? So the data set always is the first argument in a tidyverse style functions. So, so you can really expect that this works. You don't have to, for example, specify dot, right? Dot is in this case the argument for clean names. I can also show you the help file to prove it to you. Clean, oops, no documentation for clean name, mistyped. Let's go to the help pane. So dot is the first argument, right? Dot is the input data frame. And that's going to be the case for any tidyverse style function. So you can always be rest assured that that's what the first argument is going to be, and you don't have to specify it by name, as I showed you earlier as well. Now let's get to some data cleaning using the tidyr package. So the tidyr package has a lot of additional data cleaning functions that are really useful. And we have to consider that our penguins clean data set is actually not all tidy yet. So one particular thing that still isn't tidy, because there's 2 different observations within one cell, is that within the species, it has the common name, the English name for the penguin, but also in brackets, the Latin name, right? And so it's not the most important thing to clean. We could still use it this way, but for the purposes of demonstration here, we want to have the Latin name separate from the English common name. So one way to do it is using the separate function. The separate function is within the tidyr package. And the separate function takes two important arguments. Let's actually look at the help file real quick. So you can see, for example, here it tells you, right, this is the package in which you can find this function. This is the description. The first argument is always the data set, as I mentioned. And then the second one is the column that you want to separate, essentially. And then into which new columns do you want to separate it into? And then set is what is the separator between the columns, right? So I've already prepared this here, so let's go by it step by step. So first argument, data set. Second argument, in this case, is the column. Another particularity about tidyware style functions is that you can specify the column without the need of doing the $ thing, right? So the $ thing is something that occurs within a base R style writing, and within tidyverse you don't have to keep repeating the data frame because it knows that the variable belongs to a particular data frame, right? So species is something that is within Penguin's clean, so we can just specify species without quotation marks. That's how all tidyverse style functions work, right? And actually here I passed it by naming the arguments, but in a different order than the which are aligned here, which is totally fine. You can do that, right? So I'm separating Penguin's clean specifically for the species variable, which has both the common name and the Latin name. I want to separate it by the opening bracket, right? Because that's the bracket that separates the common name from the Latin name. But also importantly, behind here is what is called regex or regular expressions. We're not going to go into that, but regular expressions have specific special symbols. And these are things like brackets, but also dots. So if you have these kind of special characters, you have to escape them, which you do with these two slashes, right? So don't worry too much about it. Just if you have these special characters, you have to do // so it recognizes that you actually literally mean the opening bracket. You don't mean the special function of opening a bracket, right? You mean the actual character bracket, right? So that's why these two slashes are there. And then we want to separate it into species. That's just what it was called before. And then Latin name, which is now behind the opening bracket, right? So if I run this, we now have two more columns. One is species, which is just has a species. And then there's also Latin name, which is now separate from the species. So that is how we could tidy up the data frame. There's one more thing is there's also a trailing closing bracket. Again, not the most important thing, but we might want to remove it, right? So one way to do it, okay, so I already did it here, is the very powerful string R package. So string R, that's how it's written. And string R has a bunch of functions that allow you to manipulate strings, text essentially, right? And when I said like regex earlier, these functions are actually wrappers around regex functions, which really simplify for you to manipulate any text variables. You can also use it for natural language processing to a degree as well, right? So in order to remove then this trailing closing bracket, we can use the function string remove. The other cool thing about stringer is it's very expressive. It exactly does what it kind of tells you to do, what it tells you it does, right? So string remove removes parts of a string, essentially, right? So I could say string remove from the Penguin's clean Latin name, the closing bracket, and again, also the closing bracket is also a special symbol within regex. So that gets rid of it, right? And then I'm also assigning it back into the Latin name, right? So this is kind of like creating a new variable, but in this case, we're just overriding the Latin name that already exists, right? So if we run this and look at, okay, that's, did I, oh, I didn't, okay, errors. So unknown or initialized column. Errors are a learning opportunity, all right? So what does that mean? Unknown or uninitialized column Latin name. Well, why didn't this work? Well, it's because I ran this up here, but I didn't assign it back into Penguins Clean. I didn't save essentially the work that I had done, right? I need to put the assignment arrow here, write it back in here, so that when I run Penguins Clean, it's actually separate, right? It wasn't separate before because I just ran this particular code without assigning it to a new object. Okay, now I should be able to run this. And if I now look at Penguins Clean, it has a species and Latin name and also the trailing closing bracket removed, right? So here we used an actually useful error to debug what was going on, right? Yeah. All right, there's also a function called unite, which does the opposite. So you can concatenate essentially two variables into one, but that's not what we're going to look at today, but just that you know that this function also exists. Okay, so we kind of had a data set already that was already in a tidy data frame, right? Or almost, let's say it that way. But what if it's not the case? What if we do actually have a messy data frame? So pivot wider and pivot longer are two functions that can really help you shape the data set into the tidy format, right? So I've gone ahead and created a data set as untidy, which is under this URL. And if you read this in, and we call it untidy animals in this case, the object, we can see that this is similar to what I showed you earlier, which is kind of like a long data frame where it has not each row is one observation, essentially. So we wanted to have tidy so that each row is one observation, each one characteristic. So lifespan and ratio should not be in the rows, it should actually be the column names. And one way to do that is with pivot wider, right? Because this is a long data frame, and the idea is you make it wider again. So that's why it's called pivot wider. You're pivoting into wider. And there's two main arguments within pivot wider. There's a bunch of others. But the two main arguments you want to use is names from, and that tells you where the column names should actually be, which column names you want to use, and values from tells you where the values should come from. So now if we look back at this, we can see, well, the column names, they were within type, and you can't really see this here because it's cutting off for some reason, but I'll show you with the $sign here. It's animal, type, and value. These are the variable names within this untidy data frame. And the values are in the values column, right? So we have the function pivot wider. First argument is a data frame. Names from, that's where the type, where the column names are. And the values from, that's where the values are stored. So if we run this particular code, we have a tidy data frame again. So each row is one observation, and each column is one variable, right? That's the tidy format that we want, right? And we could also not forget to assign it to an object so that we actually saved what we did, right? Because before that it didn't, so now I created a new object called tidy elements, and that's where the new data frame is stored at. Now, we can also make it untidy again with pivot longer, right? So pivot longer does the opposite of what pivot wider does. So the first argument in this case would be the tidy animals data set. And then all we have to do is specify the columns that it should essentially write underneath each other. And in this case, it's the lifespan and the ratio variables. And if we run this, then we have a very similar data set as we had before, where there's two observations for each animal. Okay, let's get into data manipulation using dplyr. So dplyr really is the main core of tidyverse style functions, I would say. Everything I showed you so far is kind of like nice to have important kind of packages that will help you shape your data into form, but dplyr is the main sort of is the cream de la creme. I don't know. You may want to say it that way. So and there's some really nice expressive functions within dplyr that really are written exactly the way that that reflects the action that they perform, which I think is always very useful, always helps you understand what you're actually doing. So first of them is select. So select helps you select variables. So if you have a data frame which has, for example, 5 columns, and you only want to have the second, the third, and the fifth, is actually very similar how it what we actually did before. We also selected the second, the third, and the fifth column. And then we only have 3 columns left, for example, right? And we would select in the following way. So we use the function select. The first argument is always the data frame. And then we want to select from this data frame 3 variables: individual ID, sex, and species. So if you run this, we only have 3 variables left in our data frame, right? It also says here 304 times 3. So that's how you can select 3 different variables within your data set, right? And notice that here you can just specify the names of the variables. I think that's extremely useful as opposed to indexing. We did do indexing before, right? But there, the issue is you would kind of have to know where in your data frame do those variables occur, right? So you have to know, oh, it's the second, the third, or the fifth, and so on. So here you can just really just call them by name. And it's useful because sometimes the indexes change through some operations or something, and then your whole code is not going to work. But if you actually call it by the names, it doesn't matter where they're located. It also helps you from, if you just call it by the index, it might get a different variable, and you don't even notice because it doesn't run any errors, right? Because it's still valid to retrieve a particular index from your column, but you might not even notice that it wasn't the right one. So using the variable names is an important practice, I think, that goes throughout the tidyverse style, I would say. But there's also more that select can do, right? So you can also remove variables. Remember how I used the minus in the indexing? Well, that's how you can also apply it here. So you can say we want to remove individual ID, sex, and species from the data set. We use select. Data frame first, and then individually we put a minus before each of these variables, run it, and now trust me, those columns are not in here anymore, right? There's no individual ID anymore because we just removed every single mention of these columns. And it's even more powerful than that, just selecting and removing. There's all these selection helpers, and these selection helpers, they can, if you have a really a data set of 2,000 columns, but you're not interested in most of them, well, this selection helpers will really help you put it into shape into only the relevant ones. So these selection helpers, for example, are starts with. So that's keeping any variable that starts with certain text, ends with certain text, contains anything that where it occurs anywhere basically within, and matches uses a regular expression, which again we're not going to go into. The regular expression is extremely powerful to customize any to retrieve any kind of text that are text patterns, I should say, right? Regular expression is really difficult to learn. I honestly never really learned it, but nowadays one thing that LLMs are pretty decent at is testing your regular expressions, or like coming up with regular expressions that actually work. So that's what I'm referring to in this case, because regular expressions can be really tricky. Some people are really good at them, but we're not going to go into them right now. Anyway, so let's use one of them, like the starts with, for example, to select variables within our penguins clean data set. So we want to select all the variables that start with S, right? Pretty straightforward. What variables start with S? Well, it's study name, sample number, species, and sex, right? So these variables start with S. We could also, you could also say, does anything start with O? Nothing starts with O, so this is actually 0 column, so that also is something that you will see. Something with F should be there, right? So that's, for example, flipper length, right? So flipper length starts with F and then only gives you that variable. Contains, we can also try. So for example, everything that has millimeter in there, so these are all the measurements, and then we get all the different measurements of the penguins that have the common length, the common depth, and the flipper length. Now, we're only selecting, we only have one criterion in here, but we can also mix them, right? We can say, well, we also want a sex of the penguin, right? So it's now we have the sex of the penguin and also everything that contains MM, right? But we can also do it even more, right? So we can also, for example, say remove everything that contains MM, but not flipper length MM, right? So you can mix and choose what you want to do. And yes, this works. Oh, actually comments also includes MM, right? So there's another thing that, to worry about, quote unquote, right? So you can mix and choose all of these variables and use these selection helpers as well, right? So it's a really powerful tool to do a horizontal squishing sort of your data set, right? So if you want to like make your data set horizontally smaller by selecting individual variables. And there's an X here. Interesting. Is this okay? Well, this is just a bug, a visual bug, I suppose, because this works. Okay. Anyway, so more ways to select. I actually haven't shown you this, but I think it's also quite useful. I've shown you a way to create a vector that looks like this, right? So you have a vector 1, 2, 3, 4, 5, and you have to specify each value of the vector, right? But there's actually a simpler way to create a sequence of numbers, and that is with a column, right? So this column here can essentially be read as from and to. So, or just 2 in this case, sorry, from 1 to 5, right? So this actually creates a vector from 1 to 5. So that is what the column does. And in select, we could also say select the first 5 columns, and that would be 1 to 5. So here you can also do the indexing by numbers as well, right? So you don't actually have to specify it by name, but again, for the various reasons I outlined before, I would recommend you to actually name the things you're selecting, because the order might change, and then you might not notice that the order changed, and you don't know that you made a mistake. And this column can be leveraged for something else that's quite powerful, which is you can also do the from variable to another variable by using this column as well, right? So, for example, if you look at the data set and there it has individual ID, let's actually run this data set real quick. There's individual ID and then flipper length millimeters here, right? Let's say, actually, we don't care about the island or sample number and all that stuff, right? We actually just want to have the individual ID up until the flipper length, right? So we can then just select in the same way we did with the index of the index numbers. We select it by from individual ID to flipper length, and that gives us a smaller data set in width of just these variables that we want to select. Okay. So far, we've talked about selecting, which is, again, the horizontal squishing. Call it squishing, you know what I mean? And then we have the filter, which is actually vertical squishing, right? I'm going to stick with squishing now, because that's what I started saying. So if you want to have a smaller number of rows, then you would go with filter. So in fact, this is the same thing we're doing with indexing. It's just more expressive and I think more easily understandable, as we were doing earlier, right? So again, the first argument is always the data set. I'm going to keep repeating it because it's just what it does. And then filter wants you to provide a logical test, just as we did earlier, right? And because it's a tidyverse style function, we don't need to specify the $sign here, for example, right? So we can say we only want the penguins from the island Dream. You might call it the Dream Island, right? So that's where the penguins reside, I suppose. And now we can see, for example, it has 124 rows. And if we look at the island variable, unfortunately, it's a bit cut off, but it starts with Dre. So you can imagine these are all the penguins that are situated on the island called Dream, right? And actually, let's take a look. Do table. What other islands are out there? For example, Torgerson, right? We could also just filter only the penguins that are on the island Torgerson, right? And there is then only 52 penguins, right? So that might be really useful. You might only want to look at men or women in your data set, or any other filter that we want to apply, right? And you can also use the good old percentage in percentage operator that helps you filter by multiple values, right? So one thing you could do to filter by both Dream and Biscu, I suppose, is say equals Dream, that we had done that before, right? Or island equals Biscu, right? So we could do this, and that would give us penguins of an island both Biscu and Dream, right? And that would work. But if you had a lot of filters, you would have to keep repeating this, right? A million times. And that's not ideal if you want to write readable code, right? Also debuggable code, because you don't know where the error is if anything goes wrong here. So with the percentage in percentage, then, if you run it this way, so you first assign all the islands you want to keep or check for example, into a vector, then you can use island in lines to keep. So check whether anything of this occurs in here. And if it evaluates to true, then just keep it, right? And this is the same way as I showed you before of all the bars, but just a more clean way to write it. Someone asked if we have the exercises for part one, the solutions for them. You will receive them afterwards. So you will receive an email with the solutions as well. Okay, so let's get to mutate. So mutate is a way to create new variables in your data frame, right? So that we did earlier by assigning things into the $sign, essentially. That is the equivalent within the tidy data frame. So the way it looks like is you define some kind of variable name within mutate. You perform some kind of calculation or some kind of string manipulation, whatever you want to do. And then and that's it. That's basically creating a new variable within your data frame, right? And also it attaches at the end of the data set, importantly, right? So to illustrate this, let's say you want to create a variable called body mass kilogram, which has the body mass in kilogram rather than grams, because right now it's in grams, right? So we use mutate data frame first. This variable name does not exist yet, right? We're going to create this variable name, and then body mass kilogram equals body mass gram divided by 1,000, right? And that attaches a variable at the end of your data set that has this variable name with this calculation done, right? So we do this, and we go all the way back to the end of the data frame. This is body mass kilogram, and it has it now in kilogram, right? So that's how mutate works. And again, we should not forget to assign it to an object so that we actually sort of save the changes that we made, right? So we just changed the we just manipulated the object, but we didn't save the changes we made to that object, right? So that's why don't forget to assign it there. Yeah. Well, here I do a selection that's just so that both of them exist now, right? If else is something that is really, really useful when you do recoding. So if else is kind of like a shorthand. We talked about if else shortly earlier within the Python framework. If else is also a function in R, which I also use all the time, and you will use all the time as well for recoding variables. So, for example, or first of all, the way if else works is the first argument of if else is a logical test. So this is the same kind of logical tests we talked about all the time. The second argument should be telling if else what should happen if the logical test evaluates to true. And the third argument should tell it what should happen if it evaluates to false, right? So a very basic example would be if 1 equals 1, then this character vector should be put out. And if it doesn't equal 1, right? What happens if the test is not true? Then this one should be put out. Pick me if test is false, right? So logically, because 1 does equal 1, we should get this output rather than this, right? Because this is the one what should happen if it's true, right? So if you run it, indeed it says pick me if test is true, right? And that is what happens. If we say 1 does not equal 1, a statement that is false, then this one will be selected because this one is the argument that tells it what should happen if it's false. So what should happen if it's false? Pick me if test is false, right? Exactly. So why am I telling you about if else? Because you can integrate if else within your mutate functions. For example, because you want to recode the sex of the penguin, right? So we use mutate. Again, first argument is first argument is the data set. Create a new variable called sex short, and then within this calculation of a new object or manipulation of a new object, we would say if else, right? If else the sex variable, and again, because we're in a tidyverse style functions, we don't have to do $, or something. If the sex equals male, then assign it the variable m, or the value m, and if it's not male, assign it the value f, right, for female. Now, if you run this and look at the, and because it's mutate, it's attaching it to the very end, right? We look at the very end and see that now there's a new variable called sex short, and that now has the m and the f, or either male or female. And importantly, something I wanted to mention earlier as well is, well, this is just a binary test in a way, right? It's like, if it's not male, it's female, right? But that's not always true because there's actually some values here that are an A, right? Where we don't know the sex of the penguin, right? So in this case, that if that would strictly evaluate NA is also not male, right? You keeps the NAs by default, right? Because NA means unknown, so it could be male. So in this case, it just keeps it as NA, which I think is also what is the expected behavior, I should say, right? Because we don't know whether this penguin is male or female in this case. So it should not assign female, and it keeps it that way. Good. So by default, NAs are kept as NAs. Not always, but in these functions they do. And then let's just look at the comparison, right? So this is actually what it did. Male became male, female became, male became M, and female became F, right? Now, these are for binary recoding operations, but the plier package actually has a very powerful function called case-when. And this case-when function has many more conditions that you can apply that will most likely be often occurring, because you don't just test, male or not or something like that, right? There's actually much more conditions often that you need to apply to your data set. So the way case-when works is typically you do a case-when, you write out the function, and then you do an enter, so it's a bit more readable. We'll be seeing it in a second. Then you perform a logical test, and then there's a tilde, this symbol here. Well, I shouldn't highlight it, but this symbol here. And then what should happen if this test evaluates true, right? And then you have an additional logical test that then you specify what should happen if this test is true, and so on, until at the very end, where you can just say true, and then it says what should happen with everything else that I didn't test for. So this is kind of like if, and that part is else, everything else, right? So that's how you, because it says true here, essentially that means it's a logical test that's always true for all the remaining ones. That's how you can think about it. So it has been unclear. Let's look at the example. I think hopefully that makes it a bit more clear. So let's have a numeric vector. It goes from 1 to 50. We define x as 1 to 50. So now we have a numeric vector here. And then we can say case when again. So if you write out case when, ideally you do an enter after it. And you say x in 1 to 10 tilde 1 for 10, right? So that means all the values within 1 to 10, 1 to 10 within x should be assigned 1 for 10, right? So that's kind of like how you can create a categorical variable or an ordinal variable from your numeric one. And all the values that go from 11 to 30 within x should be assigned 11 for 30. And for all the rest, it should be assigned above 30. So that's everything above 30 until 50 in this case, right? So if you run this, it gives us a vector of the same length. The first 10 would be 1 for 10, 11 for 30 would be 11 for 30, and the rest is above 30, right? So an important thing about this process within case when is that it's greedy from the top to bottom, right? So if these have already been assigned, they cannot be assigned again by the ones below, right? And to showcase this, let's do the following. We can say everything that's 1 between 10 should be assigned 1 for 10, right? But then the next condition says everything from 5 to 30 should be assigned 11 to 30, right? So here actually the logical tests are conflicting, right? Because this also has some values from here. But the way case when works is it assigns everything that's from top to bottom first, and these tests below only refer to what is not been tested yet, essentially, right? So if I actually run this, it's the exact same result because 1 for 10 have already been assigned and 5 to 10 are not available anymore for this test, right? So it's kind of like a fail-safe a little bit, right? In case you have any conflicting ones, but it's also like, it also shows you that it really matters in which order you're defining these tests. Okay, so this is case when outside of a data frame operation, but now we want to use it again within mutate to create a new variable, right? So in this case, we have the mutate variable again, and the first argument is the data frame. And then we create a new variable called island short, similar to how we did it with sex earlier. And so island short equals case when. Again, if you do it with the enter, it's going to be a bit more readable. So if island equals Torgerson, then assign it the T. If it's Bisco B and if it's Dream D. And notice how we didn't do like the true in the end, right? Because in this case, there's actually only free values for your island, right? So we don't have to specify else if our ifs are all of the are already exhausting sort of all of the variables that are there, right? Okay, so I'll show you one more thing that makes it a bit more complex, but that really like highlights how powerful this case when can be. So here we said if the island is Torgerson, then T, right? But we can also say if the island is Torgerson and the sex is male, right? Then that would be T male, for example, right? And then we could say if if the island is Torgerson and the sex is female, then we could assign it as F male, right? So we can also mix in each individual row of conditions what kind of conditions we want to apply, right? So it's at the very end, of course, as it would be. And then, right, we have Torgerson male penguins and Torgerson, oh, sorry, I said F male, that makes no sense. It actually should be T female, sorry. because it's the same island, of course, right? Yeah. Anyhow, so someone's laughing at me, but it's very valid to laugh at me in this context. So T male and T females, right? So you can mix, right? You can mix conditions within each row here. Okay, let's keep it like this. There's a couple more functions I want to show you, not that many more, but one is rename, and rename allows you to, as it really says, rename a particular variable. So similar to mutate, again, always the first argument is the data frame. Then you say sample, which is not a variable that's currently existing. And then you say equals sample number, which is the variable name within the data set currently. So it renames sample number to sample. And that's all it does. And it actually does, that one does it at the same spot within the data frame, if I would find it. Sample here, right? So before it would be sample number. Trust me, it's cut off, but it did rename sample number to sample in this case. If you don't trust me, I'll show you 1 second, because why not? Names along this data frame is being created, and you can see that one of the names is sample, right? So I didn't lie about it. Okay, a range can also be useful if you, for example, just want to know which of the penguins has the smallest or longest flipper length. So we have a range. And we specify by which variable we want to sort, because it's essentially just sorting. And by default, it's sorted by the lowest value. So this Adelaide penguin has the smallest flipper length of all the penguins in the study. You can see it here, it's 172 millimeters. And then there's also the descendant function, desc function, which basically tells you, or tells the function to order by descendant values. So you want to know who the biggest boy of the penguins is, the biggest boy or gal, I should say. And that one is this penguin with 231 flipper length, right? Okay. Group by and summarize is essentially the semi-final thing I want to tell you, which is a really powerful set of functions that I find in other programming language much more confusing and much less straightforward. And even in base R, if you want to conduct an operation by a specific group, like the mean between two genders, for example, or the average height between the islands or something like that, it's very not straightforward. And here with group by and summarize within the R tidyverse framework, it's very readable and very straightforward to calculate these metrics. So I'm going to give you an example. So first of all, the group by function works kind of like as a marker. You want to tell the data frame in which way it should be grouped, right? So we use group by. Again, first argument is the penguins data set. And here, in this case, you want to group it, for example, by sex, right? So we could calculate some kind of metrics by sex. So, sorry, I just got distracted real quick because I think a lot of people are not able to retrieve the data set, right? So can people just indicate whether it worked for some people to retrieve this data set? Because I just want to make sure that it's working at least for some people, and for others, I'm not entirely sure what it causes. But is it working for some people? I retrieved it now. Okay, it's working. All right, good. All right, good. So I'm not sure exactly why it's not retrieving for some people. Maybe, one possible thing is that you're so many people and you're trying to retrieve this data set and like a server goes down or something like that, right? So so that might be it, right? So I'm sorry about those things, but okay. All right, good to know that it works for people. All right, okay. So group by. Group by marks the data set, so to tell it by which variable you want to group it by, in this case by sex, and it will conveniently tell you that this data set has been grouped by sex up here in the top within your data frame, right? And in this case, the free refers to that there's free groups, in this case being male, female, and NA, right? Because it treats NA as its own group, as it also should, right? So we've grouped it, but we haven't saved it, important. So this data frame we're going to create for this operation then means that this is the grouped data frame. And now we can perform a grouped operation on this group data set, right? So for example, by using summarize, and you notice here both American and British English will work out the same, right? Because they have both were defined essentially. So the first argument is the data set, as always. And summarize works similar to mutate, where the first thing you do is specify the variable name that you want to create, because we're creating a new variable essentially here. And then we say equals the operation we want to perform. And in this case, we want to have the Kalman length of each penguin, the average Kalman length, not of each penguin, but of each sex of the penguin, right? So we want to perform a grouped operation by sex in this case. So another important thing, there are some NAs in that Kalman length variable, right? So if you look at Kalman length here, we can see there's some NAs here. And mean does not naturally like ignore NAs, right? So you actually do have to specify this particular argument here, which is na.remove, which stands for na.remove, and you have to set it to true. Otherwise, it won't work, because otherwise it can't perform the calculation essentially. By the way, I don't think I've mentioned it, but I should mention it, which is if you just write T or F, these are just short for true or false. And you can see that because in the syntax highlighting, conveniently, it shows you that this is a specific value. So you should never overwrite T or F. And I've done this in the past actually as well, because T or F are actually logical values defined in R. So yeah, it can happen, but leads to some unintended consequences potentially along the way. But try not to overwrite T and F. Okay, so T and F are just shorthands for true and false. So we run this, and now we get the average Kalman length for each sex of the penguin, right? And we can see, for example, that female penguins have somewhat smaller Kalman length than men. And actually, if we look at NA, one thing that could tell us, for example, is that since this average Kalman length is also much smaller than male, maybe a lot of the unknown sexes here in this case could be female as well, right? But I've not done a study, so I can tell 100%, but that would be my guess. Okay, so that's how you calculate the operation by group. Okay, and we could also just keep the same data structure, not aggregate it, because in this way we just aggregated it, right? We have now one row for each sex of the penguin, right? But we could also just use mutate actually on a group data set, and that keeps the initial structure intact, and then also just attaches the average Kalman length at the end of the data set. But in this case, let me show this to you, PJ new. And then we do PJ new. Let's select. Oh, average Kalman length. And then, so it's now the same number of rows, and this average Kalman length repeats itself per sex, right? So for example, all the penguins that have a male sex are 45, and all the female ones are 42, right? So it keeps repeating itself. That's basically if you want to keep the structure of your data set, but for some reason want to have the average alongside it. You could, for example, have the average and then have a difference score for each penguin from the mean or something like that, right? That could be useful in these contexts. And then finally, we should not forget to ungroup your data sets, because if you keep your data set grouped and you perform any operations on it, you might have some unintended consequences, right? Because it always performs the operation then by group rather than by row, as you typically would want. So the ungroup function just means that you can ungroup now in a data set. I'm gonna skip it. Count is just another way to do table essentially, and I do this all the time because it's a bit more powerful than just a table, right? You can count, for example, how many species there are, how many penguins there are by species, but you can also add more variables like sex, for example. So you have how many species are there by, how many penguins are there by species and sex. And then there's also island, for example, right? So you can combine and count the number of penguins by all of these different categories, and it gives you back a data frame, right? The Google Colab does not have ungroup, so I'll just paste it real quick into the chat. Oh, I wrote it to the wrong person. Sorry about that. Here. Okay, so finally, the final thing I'd like to show to you today about the tidyverse is the pipe operator. And really the way I've shown you the usage of tidyverse style functions is not the way that it's finally typically being used, because ideally you'd use it with this pipe. I haven't shown you the pipe from the very beginning because I think it's a bit confusing to show it right off the bat without explaining what the functions do, right? But I think that this is a very crucial aspect of tidyverse style functions, because it means you can get to write a data set only once and then create a data manipulation pipeline with those pipes. And to consider why this could be so important is, so we've typically, like, we've run like individual operations, like selecting and filtering and mutating and so on, and done it like once, right? But in practice, you will, it's going to be a pipeline. It's going to be more things that you're going to do on top of each other, right? So your script might look something like this, right? So you have your data frame, you're selecting certain variables, then you're filtering to maybe some just a specific island or something. Then you want to create new variables and rename the variables and so on, right? And so each time you would have to essentially create a new object where you save this, right? And then you also seen me always forgetting to save the changes I made. And this is actually a very common error in a way as well, right? So this is not ideal, right? Because you have to keep overriding the same object as well. And what can happen is you may not remember that you've done this first and then that, right? And then you're like, oh, why isn't the object there that I actually created? It's because you've overwritten it again, right? So this keep overriding can lead to a lot of unintended consequences. That's not the ideal way to use these tidyverse functions. Another even worse way, I would argue, to do it is to just nest all the functions, right? So this would be like reading from within to the outside, right? So if you go to the innermost part here, which is the select functions, right? Oh, sorry, it goes up until here, right? So you could have select, and then you filter, and then you mutate, and then you rename, right? But this is a mess, right? Like no one can read this, and it's not being intended to be used this way, but it works, right? Like this does the same thing as this works as well, and it does it in one step, and then you can assign it to a new object called PG, and you've done your thing, right? But may have someone mercy on you when you have an error in here, right? So now you run this, and there's something in here, and like where's the error, right? And the tidyverse style functions, well, in this case, it's actually like kind of expressive because it says there's some unexpected symbol ASD, right? So in this case, it was kind of useful, but sometimes you just really don't know what to do or what's going on. So this style of syntax won't help you with that. Now, the piping style of writing code looks like this. So the pipe itself is this percentage greater than percentage, and it's read as and then. And the idea is that you use the data frame first. That's why actually all the data frames are always first in each function, is you write down the data set first, and then you read. You can read in sort of plain English what you're doing with these data sets and have each operation in each line. So that's the way the pipe is being meant to be used. So if you look at what I'm doing here, so even if you don't know much about coding, you might still be able to discern what this code is doing, which is really powerful, I think, right? So we have dataset penguin queen, and then select individual ID, island body mass, right? So this is selecting those variables, and then filter island to only the island dream, right? And then mutate, create a new variable called body mass kilogram, which is calculated by body mass gram divided by 1,000, and then rename, essentially create this variable ID and from the variable individual ID, right? So this is a pipeline that allows you to stack different kinds of operations in a readable manner to tell you what you've done. And now, if you have anywhere in this pipeline an error, right? So I've just included something weird here, right? And I run this. And then, in this case, again, this is not the best error I could do, right? Because here it actually says like object SSDF not found, and you could maybe figure it out. Let's say we couldn't figure it out, right? What you can do is you can comment out each line after each other, and then, hashtags here, right? So now we run the first free, right? Let's see, still an error, right? So what's going on? Well, let's comment out that line as well, right? And then we comment this one out, and then there's still an error. What's going on, right? We comment this line out, and then we should also have this line going out, sorry. And I should run it from here. And now this runs, right? So we know that the error is somewhere between this one and this one, and it must be here. And if we look closer at it, it's this SSDF, right? So we can remove all these pipes and check each individual step that we're running. And that is a really powerful tool for you to debug your code. And debugging is an essential part of coding. And that's why it's super useful. And you can do that, for example, with group by, right? So group by, now all these functions make a bit more sense maybe, right? Because it's like you have the data set, you group by sex, you summarize, have the average column length, and then you ungroup again, right? So you can all do that in one step and have the same operations that we did earlier without having to create a data set that is grouped and forgetting that it was grouped and so on, right? You can all do in one operation, right? And here's a small meme that I created about maybe helping you to remember, right? So the data frame, the tidy style syntax would be you waking up in the morning, then getting out of bed, then getting dressed, and then leaving the house. And you should try to avoid the way that my mornings look like most of the time by going inside out and stumbling out of your bed, right? So ideally, you would write some code like this. Each operation you want to do in one line underneath each other so you can easily debug. A small note on the pipe before we go into exercises. I would say that there is a new pipe that is now within the base R framework, right? So the pipe is coming from the tidyverse, but now since R 4.1, which is I think last year or 2 years ago or so, there is a new pipe, and this pipe looks like this. So it's a bar and smaller than sign, but it doesn't have the same functionalities as this percentage pipe that has been existing for a longer time. And there's a little bit of debate going on in the R community, and I'm trying to be controversial or something like that. But I think as long as this pipe doesn't do the exact same things as that pipe does, it kind of breaks a lot of code. So I don't know, I don't like it. So I keep using this pipe code for now. But feel free to use this base R1. It doesn't have any dependencies, right? So there is a strong argument you don't have to install a package to get this pipe. Anyhow, that's a note on that pipe, and hope this wasn't too controversial. But now I want you to engage in some exercises. And because we're already a bit late, I think what we're going to do is I'm going to give you 10 minutes to try these exercises yourself. You can get as far as you can in these 10 minutes. We're going to discuss one of the tasks, which is essentially just an amalgamation of what we just did. And then we're going to go into a Q&A because I don't want to keep you so much longer than the sort of agreed upon time. But we're going to start a Q&A at 2 p.m. Amsterdam Standard Time or Central European Standard Time. And then, yeah, you can ask me some questions about this. You can stay a bit longer, of course, but I want it so that you have some time now to conduct the exercises, maybe ask some questions in the time. And then our time is almost up. Yeah, but please now use the time to do a bit of exercises by yourself. And again, the solutions will be sent to you. So the exercises are within 04 exercises2.rmd. Within the Google Colab, they should be just in the second Google Colab that you have. And that's what they look like. Penguins. You're going to work more with the penguins data set. Okay. People saying thank you, but we're not at the end yet. But but I appreciate it. Thanks. Yeah. Someone's raising their hands. Yeah, feel free to ask some questions right now.
Yeah, my name is George. I wanted to find out, there's a link in the chat window which directs us to where to find the materials. I've opened it, but it seems to take me back to the form that I completed to register for the course. It doesn't give the.
Someone has a link right now, maybe?
Yes, I can update that, Fabio. So the link will be updated after the session is over. So right now it leads to the registration page, but afterwards all the codes and all the notebooks will be updated on that page after the session.
Thank you very much.
Yes, no problem.
I'm not a doctor yet. I'm turning in my dissertation in 2 weeks, so you got to wait a little bit, man. No worries. Yeah, so if you felt confused during the session, that is very normal. I mean, I should say, you know, could also be me, of course, but it's also just a normal experience, right? I think no programmer has ever dropped from the sky, right? It takes a little bit of practice. It takes a little bit of figuring it out yourself, right? But you're not all alone, I would say. There's a lot of people that struggle as well, and there's some kind of community in that as well. And that's what I found in the R stats community, I would say. So it's a process. It's a process, yeah. But I also think very rewarding, because for me it's a bit like puzzling, honestly. You know, it's like you don't immediately see the puzzle from the beginning, right? But piece by piece you figure it out, and sometimes you don't find the puzzle. Sometimes it's a bit frustrating, but it can be really rewarding when you find the right pieces. And that's what I've learned from the programming, you know, experience. Okay. Well, just because I do want to let you go officially in time, I will, I think, skip the solutions for this one and provide you with the solutions in the end. Probably also because you haven't gotten super far. So I would encourage you to do these exercises on your own time as well. Not immediately look at those solutions, but try to, you know, do them in your own time, I think, right? So we don't have to rush through them right now, and maybe those explanations wouldn't help you as much right now because you didn't get as far. So let me start some concluding talks, as I already kind of started, right? So one thing I do want to really share with you is some is this particular slide, and maybe you can also share it in the YouTube chat, which I'm not at right now. But this slide has a bunch of more, and actually I can share my screen here. I can totally do that. This slide has some further resources to learn R. These are some of the resources that I myself also use to learn R. So above all, I would say, is the book called R for Data Science, which is a lovely book, which it's free, right? It's just hosted online for everyone to use. So it's such a nice resource by one of the most prolific R coders, I would say, Hadley Wickham, right? And it's a great resource. And that is really all the essentials that you need for data science. A lot of the things that we talked through today, but even more examples and even more exercises and so on. So I would really encourage you to look at this one. If you're a bit more of a visual learner, I'm personally also a very strong visual learner. I like to watch YouTube tutorials, so I can really encourage you to look at Daniel Navarro's YouTube channel. She does amazing stuff. Also generates art in R, which I find really cool. There's also RStudio Cloud, which is also a browser version of RStudio, which is also super useful if you don't get R to run immediately. It's a nice way to jump right into coding without having to worry all the technical stuff to get it to run. Can really recommend cheat sheets, which are essentially just overviews of functions and so on. Because like right now I told you a lot about packages and functions, and you know, you don't have to memorize them all immediately. And I didn't memorize them for a long time. I just used them a couple of times, right? Until at some point, you know, you do so much repetition, you do remember things, but it takes some time. But the cheat sheet is totally fine, right? It's not an exercise currently, at least, right? And then finally, another book, it's also quite useful, but in similar ways as this R for Data Science book. And the last but not least thing I can recommend is the Tidy Tuesday community. And the Tidy Tuesday community is a super cool community of people that every Tuesday create visualizations of new kinds of data sets that are out there. And it's really meant for beginners as well. There's some mentors and beginners, and they help each other to engage with new kinds of data sets, create data visualizations in a fun way that maybe helps you create your own projects as well, right? But then you do it together with other people. And I think, it's hard as it is already with coding. Why not also share the pain with other people? Because shared pain is half the pain. And if it's more people, then it's even less than half the pain, I would say. Okay. I've already said, if you felt confused or something at times, totally okay, totally fine. It's your first step along this journey. There's going to be a little bit of pitfalls sometimes, but it's important that you keep going if you want to do this. And other people have also experienced these issues, and it's possible to persevere. It's just takes a bit of time. But if it doesn't come natural to you, it's okay. It doesn't come too natural to most people that do this, I think. And it's all okay, I would say. And these are the official final words that I want to give you. Hopefully encouraging words for you. And thank you for everyone else here that made this possible. And thank you for all your great involvement in this as well. So yeah, I think we'll just do an official Q&A. Any questions you have about further stuff about R? Okay, I see a hand raised. Yeah, Aina, please.
I don't have a question. I just wanted to thank you because I just came across, I stumbled across this opportunity and just registered to see if this was, if this would add value. And there are very few workshops or few videos that add value in general, but these 4 hours I've been literally glued to my screen, and I've enjoyed doing R. So thank you so much for that. And seriously, it was a great opportunity. Thank you. Thank you for being patient with us.
Thank you so much. Thank you. I really appreciate it. Thank you. Thank you. Yeah, and please ask me things that go beyond, should be R, but beyond what we learned today, for example, right? But if not, if there's no other questions, I'm also happy to oversaturate it sometimes, I know I talked a lot about stuff here. You're all very welcome, and I thank you all for your nice words. Is there anything in the YouTube chat, for example? I'm not monitoring the YouTube chat, I don't know. But otherwise,
No questions so far, just also thank you notes for you.
All right.
In YouTube.
You're all very welcome, YouTube peeps. This one's for the YouTube peeps. Here's a question. Annie says, Leah says, do you have tips to gradually transform SPSS to R? So I am one of these people that transferred from SPSS to R. In my bachelor's, I learned SPSS, and I would say, yeah, so for me, what really enabled me to learn R was the framework of R Markdown, because what I initially did when I learned SPSS is I always wanted to look at the data and how the data changed, right? And I wanted to see the data frames. And if you were within raw R, if you're just within a raw R script, it's tough to always have the data set in front of you, right? So there's ways to do it, but it really confused me that I couldn't see what was going on with the data. The code was the first thing I saw. It wasn't the data that I saw. And then that confused me. So for me, it was helpful to have these R Markdown chunks and always the data frame. You've maybe seen me always scroll up and click through the data, right? So in a way, that's not the best coding practice in a way, because like, you know, some hardcore coders will tell you like, you should write everything out and it's very specific code. But I think, you know, visual helps are quite useful, are quite important. And there's no need to make things more difficult or something like that, just because you're some kind of coding purist or something, right? If there's some kind of tool that helps you click through things, that's also good and helpful, right? I do think that coding has a lot of upsides for reproducibility and so on, but yeah, so I think R Markdown is something that I find useful. Yeah, always being able to look at the data. That will help me. I think someone had their hands up, but then went away again. Well, okay. All right. And I think we can do an official end. I hope you had a blast. And I certainly did. And I wish you all good luck on your future endeavors in R. All right. Now it's vibing. I like the music though.